HP turbine and IP turbine. And when it is injecting the hot air in HP and IP turbine, actually it is warming up the turbine. It is warming up all the steam path for the HP and IP. And at the same time, to get rid of overheating of the LP part, we are injecting the cold air in the LP inlet or HP or IP exhaust. It is mixing up so that the LP turbines are not unduly heated. And then we are taking this mixed air from the gland stream exhauster. So this is what is the solution. And this is the standard solution. And you see there, when we have the natural cooling, then you have the curve, that is the blue curve over here. And if we install the steam turbine heat conservation system, then you see the temperature gradient is much lower. That means you can make the steam turbine rotor is much hotter with respect to without HCS. And this is the standard configuration for the turbines, where we have maybe 1 HP, 1 IP, and 2 LP. And with that, based on plant to plant, if the turbine configurations are different. For example, sometimes you have a very longer loop pipe. So you have a long pipe from the main steam stop valve to the control valve. And there we have another auxiliary system. We have another air injection line, so that the loop pipes are getting hot always. And also we are doing some extra piping. We are taking out the bypass steam and hitting it the reheat line and CRH line. So those kind of modification we are doing plant to plant. And with that, we can make our steam turbine keep in the warm start position. Now, before we go to operational feedback, now this air, it is only flowing when the geometrically it is streamlined construction. But somewhere like valves and all in the steam turbine, those are the heavy mass, where also we need to keep the valves warm. There we can use the heat tracing, and which is a little expensive, but we are using as minimum as possible, considering where the geometries are a little bit complex, where your hot air is not flowing naturally. So there we can keep our hot insulation, and with hot insulation and this hot air system, we can keep the complete steam turbine in a warm start ready. And this system, GE Vernova has already installed few plants in America, in combined cycle power plant and thermal power stations. And there, if you see the results, and this is the result, when you have the heater stop, or when you have the steam turbine unit without heat conservation system, then you see the temperature gradients there. It is very quickly getting down. And whereas we have installed the steam heat conservation system, there you can see the HP turbine and IP turbine rotor's temperature. We can keep at almost a fixed level with a predefined, pre-designed level. And with that, we can make the turbine as a warm start ready, and we can get all the advantages. And with this, also when we are using this heat conservation system in the long-term basis, if the turbine is standstill maybe for 10 days, 15 days, and if we use this heat conservation system, then this hot air actually reducing the moisture in the steam turbine. And when it is actually we are injecting dry air, so the corrosions due to the condensation and all, that's also getting reduced due to this heat conservation system. So it is a kind of preservation as well for the steam turbine and all the rotating parts. In India, this system is quite new. Nobody has installed so far, but considering all these new kind of load mix is coming, where you will be having the scenario of switching off the turbine maybe 1 to 3 days. That time, you may realize that such type of system will help you in the operation and your business. Today, we are working on one of our own steam turbine in NTPC Solapur, Super Thermal Power Plant. There we have started studying one unit, because before installing such kind of steam turbine heat conservation, you need to do some stress analysis and finite element study, that what temperature is really suitable to make it continue for a steam turbine. It should not be so high that it is getting undue stress, and it should not be so low that you are not actually getting the benefit of warm start. Again, the turbine is starting from the cold start. So all this study and all, it needs some time, it needs some calculations from MI and rotodynamics. So those studies we are doing for the Solapur plants, which is with NTPC. We will be submitting report maybe in few weeks, and then possibly we will go for the implementation. So that's all from our side. Thank you so much.
Basically, this technique is only for cold startup.
Yes, sir. Because with hot air, we have checked it. With hot air, we are not being able to manage the temperature like 450 or something like that, which is actually the start permissive for the hot start. But around 320, 330 is the right calculation and right design, and that and if we can make it around 320, 330, then we are getting the warm-up permissive, not the hot start, sir.
Does it have any effect on the auxiliary consumption, because you are using heating coil for the air heater?
Sorry, sir, come again.
Does it have any auxiliary consumption? Auxiliary consumption of the power plant may also increase?
Sir, actually, the heaters which we are using, those are actually electrical heaters. The power of electric heater is not too much, sir. So the expenses for running these heaters are really negligible with respect to the cost which we are incurring for the cold start of the power plant.
Cold start as well as auxiliary, corresponding auxiliary.
How much time it will save by using this technique in cold startup? Normally, it takes around 7 to 8 hours in the unit from cold startup to the synchronization.
Yeah.
So how much time it will be saved?
Sir, we have seen almost, it is saving almost 40 to 45% time as far as the turbine startup curve is concerned. When you see the startup curve, keeping aside the boiler, if you start from the startup curve, that is the first steam injection in the steam turbine, we see normally it takes around 170, 180 minutes to get it synchronized and with the grid. Whereas in the warm start case, sir, we have seen it is almost 90 minutes, 95 minutes, where you can start injecting the steam and you can sync it to the 3000 RPM and you can sync with the grid. So that much time saving and that much cold saving we have seen it, sir.
Thank you.
Sorry, sir. Sir, costs are actually, it is only auxiliary cost, and for NTPC we have not actually calculated the cost, sir, but we have seen it in America and all. That is definitely within, sir, maybe 8-9 crore, not more than that. Sir, 660 now we are doing, Solapur is 660. In America, sir, we have done combined cycle as well, and we have done also 900 megawatt, the G3 machine, sir. Because G3 frame is the higher power output machine, sir. Normally 900 and above.
Hello. Is there any application or you are still studying the cases?
Sorry, sir?
Is it, are you applied your product in anywhere in India, or still it is under, stages?
Sir, in America, we have already installed. In India, this is our first project we are doing in Solapur, sir. Solapur, because that presentation we had given also in NTPC as well, and that time we worked with NTPC, and now we are just studying it, because, sir, what would be the right temperature for that specific steam turbine? It takes some study, sir. Because I was there in the plant few months back. We got all the data for last historical data, that when the turbine gets stopped, what was the stressing and all, because you need to see stress as well, sir. So the study and all takes some time. So once study is done, sir, then we have the complete report, then we can give as a piece of specification to NTPC that what would be the heater size, what kind of skid it would be, and what kind of temperature can it be maintained.
So based on your USA studies, you are telling that 50%, almost 50% time will be saved.
Yes, sir.
It's based on your American companies or American applications.
Yeah.
Not in India.
Right, sir.
So it is applicable for 500 and more units, or below 500?
Sir, in America we have done 900 megawatt unit. That is G3 frame.
So high capacity.
High capacity one.
Ultra super critical.
Yes, and also, sir, we have done one in combined cycle power plant. in
Thank you.
America.
So if you could share the report of this Solapur plant with our DVC team members also,
Right.
it will be really useful because this will help turbine to get not to get stressed.
Right.
It will be really useful.
Right. Sir, we'll try. We may not be able to share the complete report as is because it is actually under a contract. We have got a purchase order from them.
Okay.
But we can give some gist which may not this thing that we are any
The
jeopardizing any.
recommendation part at least you can
We'll give it, sir.
share.
At your headquarter level, we can also present this product in detail.
Okay.
That we will do, sir. We can present, sir, in detail.
Thank you for your questions and all the interaction. Thank you, Mr. Sherman and Mr. Ghosh, for your presentation. I request the esteemed session judges to extend a note of felicitation on behalf of Damodar Valley Corporation to the team from GE Power India Limited for their presentation. Thank you once again, Team GE Power India Limited, for enriching our conference with your valuable insights and research work. For the next paper, I would like to invite upon the dais Mr. Prasenjit Mandal, DGM, Mr. Pratik Bishwas, Manager, and Mr. Shitun Sharkar, Manager from Commercial Department, Damodar Valley Corporation, to present on the topic, Electricity Futures as an Operational Optimization Instrument. Can we have the speakers on the dais, please? Due to paucity of time, I once again humbly request the presenters to kindly keep your presentation restricted to 10 minutes so that we can accommodate more and more papers from all our presenters who have joined us. Thank you.
Good afternoon, respected dignitaries. Indian power sector is shifting towards a market-based mechanism in the search of more improved efficiency, better price discovery, and risk management through electricity derivative trading. Today, Shitun Sarkar, Pratik Bishwas and myself, Prasenjit Mandal, will present how electricity futures can be treated not just for financial hedging, but rather as a tool for optimizing operation and maintenance. DVC, being a vertically integrated utility, our proposed framework shows how electricity future financial instrument-driven decisions can enhance plant performance, improve PLF, gross heat rate reduction, reduce APC, SOC, and support maintenance scheduling. Electricity derivatives were launched in Indian market in July 25, now traded in MCX and NSE. It's a step towards financialization of the Indian power sector. These are cash-settled financial contracts, primarily to hedge against price volatility of the spot market. Unlike physical power transactions, these instruments allow DISCOMs, power generators, large industrial consumers to plan their optimized cost of sourcing power. However, for a regulated sector like power, participation, especially by DISCOMs, is under the oversight of the regulators. But the broader intent is clear. We are moving toward a more market-driven, risk-managed ecosystem. While these instruments are currently seen as a financial hedging tools, but using them as decision-making drivers for plant operation and maintenance optimization, we are proposing that. So the problem can be shown like this, that due to high solar penetration, particularly in the last 2 years, thermal units are increasingly forced to operate at part load, open near to technical minimum, and this leads to higher heat rate, increased auxiliary consumption and loss of efficiency, ultimately reducing the PLF and forfeiting the PLF benefits. The risk is on the revenue volatility. DAM RTM prices have become highly volatile. In the last few sessions, we have also seen that. Frequently dropping below 1 rupees per unit and even touching 0. Very recently we have seen. This creates significant revenue uncertainty and forces generators to operate at a sub-economic region. So, what is the consequence? Consequence is increased backing down and ramping. So introducing thermal and mechanical stress on critical equipments like generator, boiler, turbines, and leading to higher maintenance cost, increased forced outage, and reduced asset life. So there is a clear market disconnect. So technical optimality demands to run the units at full load. However, the persistent conflict is between engineering efficiency and financial viability. Our central thesis is very simple. We are proposing being a part on behalf of a generator, we are proposing to short futures above the marginal cost. Marginal cost is not exactly the ECR, it's something different. Higher the PLF, the marginal cost will be lower. So we are hedging the future at a higher than the marginal cost. So the financial part is ensured that hedge absorbs the risk. So it will allow the generators to run at optimal load, lowering the heat rate and higher PLF. So the profit will be ensured by PLF incentives and full cost recovery will be there. From here, I will request Pratik to continue.
Thank you, Prasenjit sir. Now, what we are proposing? We are proposing, we have two, Dvc is a vertically integrated utility, so we have our generation arm as well as our discom arm. For generation arm, we short future at the NSE MCX determined market rate, and we'll run our unit at full load, so that the part load where we are incurring some losses in the part load operation, we are gaining in that region, and we are ensuring our optimal operational parameters so that the losses can be minimized in that level. So for generation side, we will short future and run the unit full load, and we ensure the excess quantum we will sell in the spot market. Whatever may be the price in the spot market, we will sell that power in the spot market. So our revenue is sealed at a market rate. Say we have studied in our last few months data from the very beginning, from July onwards, and we have seen the average rate comes around 4.5 per kWh. And even our average ECR is much below that. So at the solar hour, even when the rate is just ₹1 and 1.5 rupee per kWh, even in that case, we are also ensuring full load operation and as well as ensuring 4.5 rupees per kWh. So in that case, we will get profit from the future position and hedge revenue at future price. We have also simulated this type of cost, and we have seen the 4.5 is constant in all cases. And in the opposite hand, we have discoms. So discoms have the risk of volatility of the market. So by hedging future, we also reduce our power procurement cost at a certain level. So having generation as discom with both hand, we have what we can do, we can netting our positions. So the margin requirement will be very minimal, and we will get the maximum ROI for that margin. And now come to the mathematical part of it. We have seen the without hedge position, the pi, that is the economic profit, that is comes around PES, that is spot price into quantity minus cost of the generation. And with future, we can get additional profit, that is future price, that is PF, minus PS, that is spot price, and quantity, that is hedged quantity. So from the efficiency augmented cost, we can see when the load unit is running on the low load, the cost is incurring higher. That is in my third part of that is Q square, that is the coefficient that is in negative, and 1 by Q, that is gamma by Q. It is also showing the part load, the cost is getting higher. So even optimal situation, we will increase the power, we will increase the generation, and we will run the unit at full load and ensuring maximum cost. Due to interest of time, I am just cut short my presentation, and apart from that, we will ensure other benefits, that is merit order dispatch, startup shutdown minimization, maintenance planning, and the renewable integration, that is the main challenge today. That is also optimized, and DISCOM cost efficiency will be ensured, and capital market efficiency can also be ensured. And we have seen the gross station heat rate by simulation. We have seen the gross station heat rate has reduced 8%. We have seen the 250 basis point, that is 2.5% auxiliary consumption and reduced, 72% specific oil consumption and reduced, and we have done an optimistic and pessimistic analysis. By pessimistic analysis, we can ensure 280 crore of profit, and optimistic analysis 420 crore of profit. Now I am handing over from here to Shitun sir.
Thank you, Pratik sir. In our simulation model, we have simulated the data almost last 1 year, and we get a very fantastic result. That is, the if we are able to hedge, then our gross station heat rate reducing, our auxiliary power consumption is reducing, and oil consumption is also reducing. But PLF, which is now in 65 to 70%, it will goes up to 95%. And for those parameters, the changing of this parameter ultimately puts a 420 crore revenue upliftment for this hedging. And not only that, in the present scenario, the marginal cost is around 3 rupees 80 paisa. But if we hedge, it is 4 rupees 50 paisa. Then this 70 paisa upliftment in unit, it will ultimately reflected in 420 crores in an annual basis. Then the whatever discussed so far, it is the what to do. But now it is how to do. How can we achieve this hedging process? And there is two parts, organizational requirements and technology and data measurement. This organizational requirement says this, there is an integration between ALDC and operation engineers, and there should be a value creation and more value creation in the operation engineers. And it is a very dynamic process, and it depends on the time to time. It depends on very fast in time. That's why specific SOP is very much required to get a efficient decision with a minimum amount of time. And not only that, a cross-functional team with finance team, operation and commercial is required to do this hedging in an efficient way. Now, from technological point of view, interface between SCADA and real-time system and market analytics, the integration of SCADA and market analytics is very much required. And optimization model also required. Develop plant performance dashboard is required, because everything is depends on the performance of the plant. That means the unit generation. That's why it's very much required. And not only that, in the last, it is not possible in present day, but in the future day when it will be fully implemented, then our system will tell how to sort and how to long and what would be the future price, and system will generate automatically and suggest some lead from that market trend. This is the last conclusion. The conclusion is that now what we are doing demand constraint operation. Operation is fully depends on the demand, but now we are converting this demand constraint operation to financially secured efficiency driven operation. And from this hedging and future electricity future, we will get from generation point of view a fixed revenue model. And this PLA increasement of plant load factor actually ultimately reduce our maintenance cost, increase our plant efficiency. And from DISCOM point of view, it will give a certainty in power purchase price. And not only that, this vertically integrated company like DVC, when DISCOM and generator both are exist, In that cases, it will reduce our total marginal cost to operate this future market. And for at the end, if we do all those things in a very optimistic way, then we get revenue upliftment around 420 crore. And if we go for a pessimistic way, then we get 220 crore revenue upliftment for DVC in a single year. Thank you.
Thank you very much. Sir.
Yeah,
Thank you,
good
sir.
presentation. And the way you were telling that 100% operation will be there, there is
Thank
no
you,
PLF partial loading. Then one suspect is there, you were telling merit order dispatch. Can it be possible in DVC for merit order dispatch?
Sir, actually, sometimes it may happen when there are sometimes may happen that liquidity in the market, future market, is minimized. In that case, we cannot sell the
I'm
power
only
in the
telling, is it possible, practically possible for in DVC for merit order dispatch ideal
Sir,
requirement?
in recent days,
Otherwise,
it may not be possible, but when we can
And
update
another
to
thing
that
is,
system.
it's a complex, and whatever I learned that our commercial department has gone ahead with this hedging problem,
Yes, sir.
implementation, isn't it?
Yes, yes, sir, yes, sir.
So it's a very good presentation, definitely, but thing is very complex.
Yes, sir.
It was indeed a very knowledgeful presentation. And now I would request our esteemed judges to kindly felicitate the team. A huge round of applause, please. Team Commercial from DVC headquarters. Thank you very much. And now moving on, you all must be aware that nowadays digital twin has become a new buzzword in technical world. So today we have Sri Santosh Kumar Kundu, DGM Load Dispatch Center, Damodar Valley Corporation. He will be presenting on development of a thermal digital twin for transformer asset.
Good afternoon to all of you. Myself Santosh Kundu, DGM from SLDC DVC. I am going to present a small presentation on the topic development of a thermal digital twin for transformer asset management. Actually, I have developed one working model of digital twin, and I will share with you about the modeling and the architecture of that only. The objective of my this work is to demonstrate the technology of thermal twin. How can we use this technology in our operational and maintenance activity in electrical maintenance? Now, what is digital twin? Digital twin is actually a digital replica of any physical asset or ecosystem, and which is continuously get trained through real-time data. To have a feel of digital twin, let's consider an analogy of an ICU bed. Here a patient, which is a physical entity, is being continuously monitored through different sensors about its parameter like pulse rate, blood pressure in a dashboard. But this output of dashboard is not generic. If you can develop a digital twin of this human by considering all the details like age, medical history, any past abnormal things, then through this digital twin, you can predict what will be its blood pressure or any observable parameter in next 1-2 hours. If you have the data of next 1-2 hours, then any abnormality can be sensed well in advance, and the doctors can take corrective action well in advance. Similarly, if you consider a transformer and we have online monitoring for the parameter like OTI, WTI, and through online monitoring, what we can maximum get? We can get a trend of last few hours, but we will not able to get what will going to happen in next few hours. Through my digital twin model, one can predict what will be the OTI and WTI for next few hours. And this is physics based, not astrological. Operational engineer can also do scenario based simulation, that if I will increase the load of the transformer by 40-50 megawatt, what will be the OTI and WTI. So it will be very important for the operational engineer as well as for maintenance engineer. If he find any deviation from the OTI, WTI from a standard parameter, then he can take the decision that maybe there some fan has been off or some hotspot has been developed. So this is all about the introduction of digital twin. Now I am directly coming to the architecture and modeling of my model. Actually, I have developed many layers in this DT engine. The first layer is actually physics-based layer, which is capturing the thermal behavior of transformer. In it, we can know that we have a mathematical equation to capture all the thermal property. Like winding temperature will depend on the oil temperature plus load square into K2. So these are the mathematical equation. So actually our purpose, if we can calculate K1, K2 or some thermal constant, then we can accurately predict what will be the load, what will be the winding temperature or oil temperature at particular load. So how can we calculate this K1, K2, etc.? One simple mathematical tool is there, Gauss-Seidel method is there, from which you can calculate K1, K2, but I have used here another layer of neural network, which in common we called as AI/ML. I have used LSTM, long short-term memory method. This long short-term memory method, a neural network actually recognizes the pattern, and based upon the pattern, it becomes trained AI/ML, and then it behaves like a real transformer, and it will do all type of prediction based upon the simulation study. But suppose you have trained your AI/ML, then how can you ensure that this K1, K2 or all the unknowns have been accurately be predicted? So here, to accurately predict the K1, K2, etc., you need very clean data. The clean data means consistent and sufficient data, because the digital twin reliability will depend on the data quality. If you do, I have built one more layer. To calculate the, to calculate different statistical value through which you can know that whether your curve has been rightly fitted or not. Here you can take one R square. R square value should be 1. But I am sharing my experience while calibrating my model. I get the R square value 0.1. What does it mean? Rest parameters are well in limit, but this R square is 0.1. Actually, I have trained my model through a transformer of 325 MVA rating from the loading of 250 megawatt to 310 megawatt. 310 megawatt. So it is not trained for the whole range of data. It can predict, since it has learned the behavior only between 250 to 310, it can predict the OTI WTI in this range only. Beyond, if we want to predict from below 250, its prediction will be maybe wrong. Therefore, R square value is coming 0.1 for me. When I have corrected it, then again LSTM, you know that it runs some training session, and its training session is known as epoch. After each epoch, its training loss as well as validation loss should be reduced. But in my model, what has happened, the training loss was reducing after each epoch, but the validation loss was increasing. What does it mean? It means my curve is overfitting. Overfitting means it is actually not learning, rather it is memorizing the thing. Why the things happen? Because what data I have taken, it is from log sheet. Log sheet data are generally entered by the operator due to some work exigency. At a stage, they have entered 4-5 hours data in one stage. So there is possibility of manipulation of data. So my neural network model cannot understand, cannot learn that model because it is not a true data. This is the example of inconsistent data, and first one was the example of insufficient data. So we have, if we bought any digital twin or we have developed any digital twin, we have to be careful that we have to give for training of that AI ML a full variability of data, full range data, then only your DT will be trained in a better manner and can predict in that sense. Now directly coming to how the digital twin is look like. Since it is not a physical entity, it is some lines of code. I have written the DT engine in Python, so I need a Python ready environment. For that I have used Google Colab, which is a online cloud and Python ready environment, and it has very high GPU. So I have used to run this DT on that Colab environment. Again, to train my AI ML or to train my LSTM model, I need 1 year of data. So I have made provision to give this input data through Excel file, and after training, it has generated one .ipynv file, which is a trained AI ML DT engine. When I get that engine, this is the whole process. When I get that engine, then since my DT is not integrated with IoT devices, so I need to give the input what we need, either for simulation, scenario-based simulation, I have to give in the form of Excel. So I have made provision to give the input which for the scenario for which we want to do the output. Here in the second, the provision is there where we can upload the Excel file for which the scenario we want the output. Then after that, it is giving the result. This result can be further be converted into any form, either in graph or Excel or PDF. We can download it from that DT engine. If you take the help of any Power BI expert, you can convert it in a Power BI dashboard where you can get the trend, prediction, or whatever result you want to draw from that. Thank you from my side. Thank you very much.
Basically, to implement this digital twin, we require 24/7 online data for the transformer, like tan delta, DG result.
No, sir, my digital twin is limited to thermal only because it is a scalable model, right, sir? I have just make it for thermal property. For DGA or for any other, you have to scale it by converting all this through mathematical equation, or through making the LSTM or gradient boosting model incorporated with that. I have not built the DGA in this, only thermal property of transformer.
Only thermal part, you have to install WTI and OTI data. We require continuously data from the WTI and OTI. No?
WTI, OTI, load and ambient temperature. These four data minimum we required, yes.
Okay. Any question from audience?
Thank you, Mr. Kundu, for your presentation, sir. I request the esteemed session judges to extend a warm note of felicitation and appreciation on behalf of DVC for Mr. Kundu's presentation. Please give a big round of applause for Mr. Santosh Kumar Kundu. There are feedback codes kept on your tables. So you're requested to kindly scan the QR codes and put in your valuable suggestions and feedbacks. So there will be QR code cards kept on your tables. You are requested to please scan the QR codes and positively send in your feedback and suggestions. I also request the team, meanwhile, to flash the QR code scanner on the screen once. I request all the delegates to positively scan the QR codes and put in your valuable suggestions and feedbacks, which will help us to improve and grow bigger and better for the years to come. Our next presentation in this segment is on the topic oscillation management in high renewable power systems. And to present this, I would like to call upon the dais Mr. Pankaj Kumar Singh, Manager, and Mr. Abhimanyu Kumar Singh, Senior Manager from Chandrapura Thermal Power Station, Damodar Valley Corporation. Ladies and gentlemen, I request all of you to engage more and more in the sessions so that you can gain the maximum out of this O&M conference and also put in your contributions. Thank you.
Good afternoon, everyone. I am Abhimanyu Kumar Singh, Senior Manager Electrical, CTPS, DVC. Along with my co-presenter, Mr. Pankaj Kumar Singh, Manager Electricals, we are presenting on oscillation management in high energy renewable power systems. We increase renewable integration power system face challenges such as reduced inertia, converter interaction, and oscillatory instability. In this presentation, we discuss different grid oscillations, their impact on the stability, and a proposed oscillation management system for the improved monitoring and damping control. Thank you, and let us begin. The challenges in modern power system. Modern power systems are rapidly shifting towards renewable energy sources like solar and wind. The replacement of synchronous generators with inverter-based resources reduce grid inertia and increase control interaction. Traditionally, stability methods mainly focused on voltage and frequency, but RE-rich grids can experience poorly damped oscillations even under the normal frequency condition, threatening overall grid reliability. Next slide. Need for OMS. To manage this challenge, oscillation must be treated as a real-time operational risk. Continuous monitoring, fast detection, and active damping control are essential for a stable grid operations. We therefore propose an oscillation management system combining PMU-based monitoring, VHC, HVDC in modulation, coordinated reactive control, and grid forming inverter support for the faster and more reliable stability response. There are different types of oscillation observed in grids. The first is local plant oscillation occurs at generating station are generally associated with excitation or controls issues. And another is inter-area oscillation occurs between the group of generators separated by long transmission distances. And another is the converter and control oscillation are increasingly common in the renewable rich system due to the interaction among HVDC links, converters, weak grids. The subsynchronous oscillators occurs below the synchronous frequency and often linked with the series compensation and converter interaction. Another is force oscillations are caused by the external periodic disturbance such as cyclic loads or faulty controls. Finally, voltage and reactive power oscillation arise from reactive imbalance and dynamic voltage interaction in RE-rich networks. I hand over to Mr. Pankaj for next slide.
Impact of high renewable penetration. Impact of first is reducing inertia. Inverter-based in modern power system, we are replacing the synchronous machine with inverter-based system, and due to this, total inertia finally decreases. Second is the inverter-based system is far from the load, and due to this, the due to this weak receiving system, synchronizing torque and stiffness are reduced. Third is increased voltage sensitivity. A small voltage variation in weak receiving system can transfer the oscillator energy into mechanical mode. Next is controller delay and controller delay. When converter or communication delay become large, the control action become out of phase with the oscillation, and finally this delay induce the damped oscillation in the system, and controller may inject the negative damping, finally cause oscillation to grow. Such delay may originate from phase locked loop dynamic communication latency and signal processing or digital sampling delay. Second issue is capacitor or reactive discrete switching. Capacitor or reactive switching can create sudden voltage step in the system. This disturbance may excite poorly damped oscillation mode and increase the instability risk. Next is the combined effect on eigenvalue. Eigenvalue determine the oscillation frequency and damping characteristics of the power system. When the real part of the eigenvalue is the negative, oscillation finally decay and the system remain stable. If the real part approach 0, the system become weakly damped. A positive real part indicates the growing oscillation and instability. Reduced inertia lower the oscillation frequency, while reduced damping shift the eigenvalue towards the right half the plane. Therefore, left side of the eigenvalue shift towards the right side of the plane, and finally oscillation increases. High renewable grid design and OMS workflow. In our proposed system, we have proposed that oscillation management system which work on in a step 1 it observes the grid frequency. In step 2 it estimate by calculating the oscillation mode, damping ratio, eigenvalue and important system parameters. It work on simply the state space equation, where the matrix A represent the natural dynamics of the power system and B represent the control device influence the system. Step 3, OMS characterize the most dangerous oscillation mode called critical mode or dominant eigenvalue. And finally, OMS act on the system and it remotely change the converter gain and inverter setting and damping control. Measurement detection and state classification. In this, OMS work on a wide area measurement system and signal analysis and oscillation mode. And also, it calculates the damping ratio of the system, and by calculating the damping ratio, it gives hierarchy like normal, alert, and critical, and unstable. Major actuator and hierarchical control. Major actuator in our system is HVDC, PODP, and second is grid forming inverter, third is SATCOM SVC, fourth is automatic voltage controller. In our thermal system, already automatic voltage controller is in service. And based on this, we have prioritized first, second, third, and fourth, which act first or which act last. Strategic framework for Indian grid reliability. In a strategic framework, we have first provide damping service using HVDC, IVR, and RLDC, and we have to install grid forming inverter in place of grid following inverter. Currently we have using the grid following inverter. Third is the we have taken the output of dynamic voltage security assessment, and it continuously monitor the grid voltage, and fourth is the dynamic stability monitoring. Thank you, sir.
Thank you very much.
Especially in DVC system, for example in CTPS, where we also face problem regarding the voltage and reactive power management. So what kind of oscillation system will be best suited for, especially in Chandpura area where the load demand is maximum and generation is not up to that level or 220 kV level?
At present, sir, we have no any oscillation detecting system in our DVC grid. Actually, this OMS system is designed for the Indian grid, and also for in future DVC grid also, because we have already tried to install the huge amount of renewable energy in our grid. So one day in future we required it.
So, DVC system is connected with the national grid.
Yes, sir.
It's not isolated. It's connected with the national grid.
Yes, sir.
So even if DVC installed your proposed OMS,
actually,
and
sir,
others are not installed your proposed MS, will it serve your purpose?
This system is where renewable energy system is high.
See, renewable energy all over India, not in DVC, not in Eastern region, it's all over the India. This problem, whatever you were telling, because of renewable energy,
yes,
it can happen all over the grids.
Yes, sir, happen, but
and if you install only your OMS system in DVC grid, my question is whether it will be serve the purpose for national grid, because you are telling it it's a national grid problem, and you are designing it for national grid.
It is required for the national grid, sir, not for only DVC.
Yes,
yes.
Thank you, sir. Now I would request our session judges to kindly felicitate the team CTPS. We have Pankaj Kumar Singh, Manager Electrical, and Abhimanyu Kumar Singh, Senior Manager Electrical. And next we have a team consisting of women power from Durgapur Steel Thermal Power Station. We have Srimati Sanjulata Mohanty, Srimati Saini Bhaumik, Srimati Satrupa Mukherjee, and Srimati Anupama Tiwari, and they will be presenting on pure power, the DSTPS green strategy. Over to you, ladies.
अच्छा ये काम नहीं करो Good afternoon, all the dignitaries present over here from DVC and other organization. So here we are introducing our team. Myself Sanjulata Mohanty, with me Srimati Saini Bhumik, Srimati Satrupa Mukherjee and Srimati Anupama Tiwari. So we are presenting Durgapur Steel Thermal Power Plant, a 1000 megawatt plant of DVC. So this is basically, this presentation is pure power DSTPS green strategy. So this is basically a comprehensive roadmap. It shows the transition from the conventional coal-based energy to a more green, clean and sustainable energy. So let us have an overview. These are the three pillars of sustainable operation at DSTPS. The first one is the fugitive dust control system. So under this, the dust that is generated in the plant and the periphery area, how we control this dust. This will come under this fugitive dust control system, and these are all the system that is ongoing or implemented at DSTPS. And the second part is solar steam cooking. It is using the renewable source of solar system. It is implemented at DSTPS canteen work that reduces the 60% burden on the LPG gas. And the third one is soil biotechnology. It is a futuristic approach towards replacing the conventional sewage treatment plant system. So let us move to the fugitive dust control system. So these are the system implemented at DSTPS. So first one is sprinkling line around ash pond area. So at DSTPS there are 2 ash ponds. So around 300 to 400 ton per hour of ash slurry being deposited in the ash pond using, and on regular basis heavy vehicles being movement. So due to that numerous amount of fugitive dust being spread in the nearby area and inside the plant. So we have around 1.4 kilometers of SDP pipelines have been installed and 100 number of sprinkler system provided. So due to that we are successfully reducing the impact on the nearby villages Andalgram and Gopal Mart. So the total investment is 54 lakh. And the next system is truck mounted fog cannon with a 3-side spray system. So this is also implemented at DSTPS. The existing fog cannon is highly appreciated by West Bengal PCB. So and we are moving towards upgrading it with 3-side spray system. Here the investment is 31 lakh. And the next part is, so the third one is the vacuum based road dust control system. This is in the NIT stage, and this will provide, because the most dusty area in the plant is ash pond, NS19, silo, weighbridge, RCP and gypsum corridor. So this process will efficiently control all the dust being generated in the road, and this truck will move on continuous basis and will collect through the sweeper cum dust sucker and will effectively control the fugitive dust in the plant and the periphery area. And here the investment is around 1.27 crore. And the fourth one is in-house bulk washing system. So after collecting all those ash from the ash pond, this bulker is being highly loaded with dust. So the in-house development of this system has been done by using the scrap material from DSTPS, and it is successfully cleaning the bulker before moving outside the DSTPS, so that we can completely keep the housekeeping in control. We can control the housekeeping inside the plant and also in the periphery area. And here the investment is negligible. So next I am giving the slide to my colleague.
Shift our focus to utilizing one of the most abundant resources that is available to us, that is solar energy. Now, India is naturally positioned to benefit a lot from solar thermal technology because of the high solar radiation that we receive for the most part of the years, that is almost 250 to 300 days annually. Now, this creates a strong potential for reducing our dependence on the usage of conventional fuels in the industrial and in the institutional applications where there are large canteens or community kitchens where a significant amount of fuel is used for daily cooking purposes. So DVC recognized this potential and our R&D cell came up with the implementation of solar steam cooking technology at our plant in Durgapur Steel Thermal Power Station. Now at the heart of this technology we have a Scheffler disc, which is a specially designed parabolic concentrating dish which tracks the movement of the sun and concentrates the sunlight onto a fixed receiver point for steam generation, which can be used for low or medium heating applications. I will mention a quick advantage here. Though the Scheffler disc moves with the sun, the receiving point is fixed, which makes the process of steam generation as well as the piping arrangement which will be involved in the implementation of this technology comparatively simple. Now let's understand the working principle behind this technology. It is pretty straightforward. As mentioned, the parabolic dish collectors, it concentrates the solar radiation onto the receiving section, which then absorbs this concentrated heat, and then it transfers this heat to the feed water, which generates steam. It is collected into a steam header, which helps us in maintaining a uniform steam pressure, which is then distributed to different cooking vessels. Now, the steam transfers energy to the cooking vessels via condensation, and this condensate is then collected into a condensate tank, thereby helping us conserve water. Now, this hot condensate is then fed back into this system via a feed pump, and it then effectively makes the entire system a closed loop system and helping us conserve thermal energy as well as water. Now coming to the financial and environmental benefits. So this study was undertaken for serving 200 at lunch, 100 at dinner and 250 at snacks. So it was found that an average of 2.17 cylinders was used daily at our canteen. And after the study, it was concluded that this technology will result in savings of 1.43 LPG cylinders per day. That is a saving of 66% of LPG gas. And it is pertinent to mention that with the ongoing West Asia conflict, the prices of commercial LPG gases have increased significantly, and we use that price of LPG cost to calculate our annual savings, which came to 13.04 lakhs. Add to it the carbon credit, the saving goes up to 13.08 lakhs annually. Our profit comes to 7.08 lakhs with a payback period just over 3 years, making this technology economically viable with a clear return timeline, and it is replicable across similar industrial canteen setups.
Yeah, now we will be focusing on an innovative and sustainable solution of wastewater treatment, that is soil biotechnology. I think you have heard about STP, that is conventional wastewater treatment process. We will simply see this process. So it consists of some primary treatment, secondary treatment, sometimes tertiary treatment, and then sludge handling. So in the primary treatment, wastewater is collected in the screening chamber where larger particles, plastics, and clothes are screened out. Then it converted in the grit removal tank. After that, it goes into the equalization tank. And major part is the aeration tank, where the microorganism breaks down the wastewater with the help of some oxygen supplied continuously with the help of blowers. And then it is collected in the secondary clarifier, where the sludge deposits in the bottom, and it is disposed of after sludge handling process. And the treated water is disposed of after treating through chemicals for maintaining pH. And now the SBT process, it is a natural process where the wastewater is collected in the sewage tank, and it is first screened out for removal of larger particles and debris. Then it is then it is spread out uniformly over a bioreactor. So a bioreactor is a media specially designed which consists of gravels, soils, and culture media. The culture media contains some microorganism, bacteria, and earthworms who decompose that wastewater with the help of oxygen. And where from the oxygen comes? The oxygen comes from the pores of the gravels and soil, which are trapped oxygen. Moreover, some plants, special plants are planted over the soil bioreactor, and the roots of the plant supply the oxygen, and these plants help in maintaining a proper ecology for this system. Moreover, these plants give the system a garden-like look, which is not possible in conventional STP. And ultimately, the treated water is collected in a storage tank. If we want to get a more quality water, we can use another bioreactor. So what are the comparison and benefits of STP? So whether a conventional STP is a mechanical and chemical process, it is highly energy consumption is there. It uses chemicals like alum, chlorine and acids. There are large sludge generation and water recovery is 80 to 85%, and it also produces some pollution and odor. But in the SBT is a totally natural treatment. Sludge generation is very negligible. Moreover, the sludge acts as a biofertilizer. Water recovery is about 97% and no odor or pollution is there. Now I am handing over to Shani.
Here we can clearly see the difference between how conventional SPT and SBT plant looks. There are some advantages and features of SBT. Its scalability is as small as 5 KL to 1000 KLD. It delivers zero liquid discharge and no greenhouse gas emission. One of the major advantages of SBT is that its treated water can be used in construction, firefighting and cleaning purposes, and it also improves green rating and reduce carbon footprint. This is the proposed layout of the 100 KLD SBT plant for DSTPS plant. This layout includes screen, receiving sump, grid chamber, primary sedimentary tank, lifting sump, and then 2 numbers of bioreactor, and finally the treated water again collected for use for many purposes. And this is the 2 proposed locations selected in DSTPS considering the space optimization and operational accessibility. And finally, the most important part of any new project, this is the cost impact. Here we can clearly see that capital cost investment in case of STP is around rupees 255 lakh, but in case of SBT it's around 61 lakh, which is very much low, and O&M cost drastically reduced in case of SBT, that is 0.73 lakh per year, which is in case of STP it's 13.7 lakh per year. Its payback period is around 4.7 years, water recovery 97%, which is in monetary terms 6.02 lakhs per year. These are some successful stories where SBT plants is successfully running. And finally, to conclude, DSTPS has taken green strategy through dust separation, adopting solar steam cooking and solid biotechnology. It also taken initiatives reducing LPG dependency and GHG emission. It improves eco-friendly environment and create a sustainable future model for future thermal power plants. Thank you everyone for your time and attention.
Very good presentation. I suggest that you circulate this presentation to all the thermal power plants so that they can adopt it. But I have 2 queries because your green power, you have not told us or shown that you have installed spray in coal conveyor, because there are number of pretty dust is there. You have shown everywhere the cool spray, you haven't shown it. So it's not purely your green energy. And the second is, how many cannons are you are procured? Only 1. So is it sufficient for 1 cannon, foam cannon or something? It's not sufficient. So you need to, for your legitimate claim for green energy, you need to increase the number of cannons and spread the spray in the entire coal conveyor. Okay.
Any questions from the audience?
There are some lapses, but overall, thanks to you all for a good presentation. You please circulate it. You please give it to OSU, COS, and we shall put in the domain of the DVC. Very good presentation. Thank you.
Thank you. Ladies and gentlemen, please put up a bigger round of applause for our team of very pretty ladies from Durgapur Steel Thermal Power Station, Damodar Valley Corporation. They have not only given the paper, which is very well thought of and well researched, but have also served a very good job of putting up this pretty face. Thank you. I request the esteemed judges to felicitate our team from Durgapur Steel Thermal Power Station, DVC. Srimati Sanjulata Mohanty, Shaini Bhomik, Shatrupa Mukherjee, and Anupama Tiwari, serving the green theme perfectly. So a bigger round of applause once again, please. Thank you once again. Now we have a presentation on the topic Advanced Leakage Monitoring and Alerting to be presented by team from Stiag Energy Services India Private Limited. And I would like to call upon the dais Mr. Jatinder Singh, GM System Technologies from Stiag Energy Services India Private Limited. Ladies and gentlemen, the presenters have put in months of hard work and tremendous hard work to come up with the papers in front of us, which is enriching this conference so much. So please be generous with your applaud, and please put up a big round of applause for our next presenter, Mr. Jatinder Singh, GM System Technologies from Stiag Energy Services India Private Limited. Over to you, sir.
Respected session judges and respected dignitaries and all the delegates present in this hall, a very good evening to all of you. I am Jatinder Singh, GM System Technology from Stiag Energy Services India. First of all, thank you for accommodating me in this schedule. I think a lot of presentations are there. So I was not pre-scheduled, but thank you very much for accommodating and giving this opportunity to present before you and give you an overview of a solution which is called ALMA. ALMA is basically Advanced Leakage Monitoring and Alerting. It's a predictive analytics tool which Stiag has developed for the boiler tube leakage detection. So I hope that this will be an interesting topic for you. So ALMA, as I said, is Advanced Leakage Monitoring and Alerting. Some key facts about the ALMA is that it is an add-on module, it's add-on software to the acoustic steam leakage detection, so ASLD system, which is already there installed in the boiler. It eliminates the false positive from the ASLD systems, and it detects the slowly growing leakages in the boiler before the SLD catches them alone, or maybe sometimes it does not catches the leakages which are occurring in the boiler. As I mentioned, it is based on the AI/ML based predictive analytics technologies, and let's go into the details. So as you can see that in the boiler, maybe typically 2 to 10 leakages can happen, or maybe more sometimes depending upon the boiler situation per year, per unit. And the leakages which are happening in the boiler, 60% of them are, the outages which are happening in the boiler, 60% of are because of the tube leakages. And the smaller leakages, when it starts happening in the boiler, it can cause the secondary damages, which can basically leads to the costly damage of the pressure components, and then may lead to deformation of the boiler as well. So a single hour of unavailability in a 500 megawatt unit can make a loss of 15 to 20 lakh per hours. So when I talked about the secondary leakages, so you can see in this slide basically that we have in the background, in the trend, we have the ALMA system installed, and in the background you have the raw signals from the acoustic sensors in the signal is basically the decibel which is coming. And then there's a processed signal on the front. We have alarm from the ALMA systems. So the ALMA has already given the alarm at a stage marked by number 1. And then the leakage happened in the tube 1, marked as 1. And then it slowly, basically, the leakages went to the underlining tube, which is marked number 2. And then afterwards, number 3 also, third and fourth tube, basically the leakage starts. So ALMA has detected the leakages at an early stage, and it has given the alarm. So if the corrective actions could be have taken at that place, then the secondary leakages could have been avoided. So this is a typical ASLD systems which comes with the odd number of 50 to 30 maybe sensors, airborne or the structure-borne, with cables and evaluation computer. And this is an example of the system which is already there in the boiler, with the locations of the acoustic sensors which you can see, and in the below you see the decibel, the noise levels for 30 sensors and some other process parameters. So that's a standard system which ASLD does. And then when we come to the ALMA, so ALMA gives, ALMA is basically a predictive analytics layer above those acoustic sensors. On the left side you see the raw signals, and it's really hard to detect any leakages from these raw signals, as there are many noises apart from the leakages which are occurring in the boiler. But ALMA systems processes these signals and gives a clear-cut signal that yes, the leakage has started in the boiler, and it has to be investigated, maybe physically and with some other, validation processes. And then the action has to be taken to shut down the boiler, or to, and depending upon, of course, the commercial conditions, or to basically still continuing with the operation. These are the challenges for the operators, because often the ASLD system gives false alarm, maybe soot blowing is happening, it's giving an alarm, or some other acoustic noises are present which can also lead to the alarms. And when you have a lot of false alarms, then it's basically that the operators are not basically accepting the system, and sometimes the systems are bypassed, or they are shut off maybe at some of the units, and they are not used. So these limitations are overcome by the ALMA systems, because whenever the ALMA system gives an alarm based on the predictive AI/ML technology, it is a true alarm which is generated by the system and is a reliable alarm, and then accordingly the decision making can be done. This is the installation setup. So as I mentioned, the main signals are the acoustic sensors, which is the main input to the ALMA systems. Apart from the soot blowing signals and the process data, main steam flow, and all other temperatures, soot blowing temperatures, soot blowing steam flow, and there are other parameters from the boiler side which we take into the system. And then these systems, if they are available in the DCS, the raw signals, the noise signals, then we take from the DCS. Otherwise, if they are not connected to the DCS directly, we can take it through the Modbus from the ASLD system also, through the Modbus protocol. And there is a ALMA system, ALMA servers, which is installed, which basically runs in the background. We collect the historical data for all these signals and process signals, and create a database data model, the AI/ML model, from this historical data, and then it runs in the real time and gives you the alarm. So basically it's a smart planning enabled by early and accurate prediction based on the AI/ML. So whenever you have an alarm, early alarm, for the leakages which have started in the boiler, and if there is already a planned maintenance activity in the future, then it can be used for the inspections and then correction also. and the unplanned outages can be then reduced. So briefly, as I mentioned, we take the sensor data, and along with the other process data, and there is a learning process from the historical data, the neural networks, the data model is prepared. Then a reference is calculated, and we have actual value, of course. Then the KPI is created, which could be as simple as the ratio of actual and the reference value. So ideally, the KPI should be equal to 1, but that's not the case. So there are deviations afterwards. And from this deviation, the predictive analytics technologies are used. And over and above, we also use the significance check by the statistical methods, which ensures that whenever alarm is generated, it is a true alarm of the leakages. And once there is a true alarm, then the RCA can be done accordingly. So these are some of the case studies. I think because of the time limitations, I will not go in detail, but for example, the leakages can be detected 2 days before shutdown, like this was detected in one of the installations, and 6 days before shutdown, then we have 10 days before shutdown, then 4 weeks before the shutdown. So this is basically indicating that we have always the true alarm. We avoid a lot of false alarms which are generated by the ASLD system. I'm not saying that ASLD system always generate the false alarm. Of course, when there is a large leakage, it will of course generate the alarm. But the very minute leakages may not be detected by the ASLD system because of the limitations with the ASLD systems. And we use the AI ML technologies. These are some of the references apart from our own plants, because TIAG is also an IPP company actually in Germany. So apart from our own plants, we have deployed the system in RWE Germany, in Iskenderun Turkey plant, in Hongsa at Laos, and in India we are doing the first commissioning of ALMA system in UPRV Anpara Unit 6. And in the future, coming months, it will be implemented also. We already, from the historical data, we have very good observations of this data. So I think we will present in the future these results also. And these are the key benefits which are obtained by the operators and the owners by using the ALMA systems. So thanks a lot. I think any questions, please welcome. Yeah, so we have put an intelligence layer, which is the predictive analytics layers. The sensors, we will use the same sensor. If sensors are already there in the boiler, we will use the same sensor because that is the main input to the ASLD systems.
Okay, thank you. It's a good session. Let's have a your
UPRVNL, Anpara service.
Let's wait for the Anpara results, how it's been actually proven.
Yes, sir. We are also aiming for the same.
And we are eagerly waiting for that your results.
Yes, sir. Thank you.
Thank you. Thank you.
May I please request our esteemed session judges to kindly felicitate the presenter for this wonderful presentation. Thank you. NOx are the gases produced during the burning of coal in a power plant. And the reduction of NOx gases is always a challenge. That's why we have a presentation today, a case study on NOx reduction in NTPC coal-based thermal power plants. and it will be delivered by Sri Kamal Kant, Deputy General Manager, and Amulya Singh, Senior Manager, Center for Energy Efficiency and Environmental Protection, NTPC Limited, Raipur.
Yes. Respected judges and dignitaries present in the hall, all the delegates, my friends. So, thank you. First of all, I would like to thank DVC for giving this opportunity for presenting this case study of NOx reduction in NTPC, coal-based thermal power plant. And myself, Kamal Khan, I am working as Deputy General Manager and in Center for Power Efficiency and Environmental Protection Group under Corporate Operation Services, NTPC, Raipur. As all of you know that the thermal power plants are major source of air pollution, and especially the SOx and NOx. NOx, these are the major contributors. NOx contributed around 30% of the total air pollution, and so we have NTPC has always strived to control this pollutions like PM and this SOx and NOx. So regarding the NOx, these are the environmental norms which have been issued by the Ministry of Environment, Forest and Climate Change, dated 7 December 2015. So for the older plants which are installed before the 2003, they have the limit of NOx 600 mg per NMQ for units less than 500 megawatt, and for units of capacity more than 500 megawatt, limits are 200 mg per NMQ. But we are assuming the limit of NOx 450 as we have filed a petition in the Environment Ministry. So we are maintaining NOx around 450 or lesser. For plants which are installed after 1st January 2017, they have more stringent limits of around 100 mg per NMQ. So what are the reporting format for the NOx? So as per the ministry guidelines, we report all the SOx, NOx in the mg per NMQ, which has been corrected to 6% oxygen dye basis. So these are the equations through which we can convert the NOx in the required units or required value. So generally for offline instruments, we measure in the ppm NOx that can be converted into mg per NMQ by multiplying factor of 2.05. And generally the OEM, the supplier, provides NOx guarantee in gram per gigajoule. So we can convert as and when required. So let us come to the principle of NOx formation. So NTPC has around more than 140 coal-based thermal units. So the principle of NOx formation, so the first, the combustion of coal in the furnace produces nitric oxide, nitrogen dioxide and nitrous oxide. So NOx is mainly NO plus NO2. Mainly NOx is, NO is around 90 to 95%, whereas NO2 is around 5 to 10%. And further the NO can be divided into three parts: thermal NOx, fuel NOx and prompt NOx. So fuel NOx that is from the combustion of fuel by the reaction of nitrogen which is present in the fuel, whereas the thermal NOx is the reaction of nitrogen which is present in the air in the oxygen-rich environment. And prompt NOx is the conversion of this molecular nitrogen in the flame point. This is very negligible amount, typically less than 4 to 5%. So let us see the formation of fuel NOx. When the raw coal is burned in the furnace, it is the volatile nitrogen and charred nitrogen is formed. This charred nitrogen is converted into nitrogen through the intermediate compound formation like cyanides and NH3, NO2, etc. And this SCN formation is the precursor of NOx formation. So when we have oxygen-rich environment or like high temperature environment, this NOx formation is typically high. And if we have environment of less oxygen, this NOx is reduced. So NTPC have done the modification in its around 50 to 52 units, like air staging or SOFA modification. It has provided with low NOx burners and SOFA or CCOFA, like for stage, two-stage combustion. So we can see like the air is divided into two stages. This is the secondary air duct, and on the upper side, this is a SOFA duct, so which is for the secondary combustion, and it helps in the reduction of NOx. So these are the basic methods for the abatement of NOx inside PC boilers. So first strategy, low NOx burner install. We have installed in around 50 odd units in NTPC, mostly which are installed after 2003. And NOx can be reduced by controlling excess air, or by this method we can reduce NOx by 10 to 40%, in the range of 10 to 40%. If you maintain excess air by around 20%. Air staging, the modification offers this two-stage combustion, like in the previous slide we have discussed. First primary combustion and through SOFA, secondary combustion. So it has the capacity of NOx reduction through 10 to 30%. This is the most important tool. Next is the flue gas recirculation. This recirculation is not installed in all the units, but a fewer units. Like in the case study we will see. And this is the reduction of temperature in low temperature furnace. NOx is reduced. And next is SCR or SNCR technology. So we have three typical case study. Case study one and 2 are the similar. These are the older plants which are commercial, declared commercial in between 1998 to 1996. So case study 1 is both are Russian make units, and the NOx limit is around 600 mg per nm cube. And modification is not possible because both have this radiant wall superheaters in the water wall zone. So O&M has also denied from this further modification. So we have visited these sites, and we have done what are the strategy we have discussed in the previous slide, and these are the NOx value what we get. So we have some trends like through the this O2 reduction, we achieved lower NOx, and this controlling excess air, we are able to reduce the NOx, and through gas recirculation, although in the unit this is not working, but we have seen the previous trends, and from this trend we have concluded that this is very limited. So gas recirculation, this NOx reduction is very limited, only 70 to 80 mg per nm cube. A similar trend we have concluded for the case study 2, which is similar kind of unit, but thus just only billing system is different, little bit of difference. Case study 3 is somewhat different. It is 800, it is the newer plant, and already the installed with low NOx burner and this SOFA modification. SOFA is already provided, but although they are maintaining higher NOx, more than the 450 mg per nm cube. So we are able to reduce the NOx through optimizing excess air and secondary air. So we are able to reduce NOx from 693 to 500 mg per nm cube, around 26%. So these are the conclusion. Like in case study 1 and 2, through various optimization, we are able to reduce the NOx only in the range of 100 to 150 mg per nm cube, and modification is not possible. Whereas in the case study 3, which is the newer plant, we are able to reduce the NOx around 200 mg. Further reduction is also possible, and we have just experimented on a single day at part load. So it is possible to reduce the NOx below the norms, 400 mg per nm cube. Thank you. Thank you all.
Any questions from the audience? Gentlemen at the back, you are requested to please settle down. Thank you, sir, for your presentation. I now request the esteemed session judges to extend a warm note of appreciation on behalf of Damodar Valley Corporation for your presentation. And please give a big round of applause to our presenter. Extending a warm note of appreciation and gratitude on behalf of Damodar Valley Corporation to Mr. Kamal Kant, DGM, who has traveled all the way from Raipur, Chhattisgarh to enlighten us with his deep research work and insights.
Good evening to respected seniors, dignitaries, and my colleagues and delegates. This is Venkatesh. I am from Damodar Valley Corporation, EMPC headquarters. I am going to give a presentation on a topic, new life for mature trees with translocation. To protect the environment and preserve the biodiversity and ecological balance, we can translocate the trees. It means we can relocate the trees from one location to another location through scientific methods so that we can reduce the deforestation and protect the valuable trees towards the sustainable urban and industrial development. Before going to the presentation, I would like to show one of the video regarding the Durgapur power plant, which is the expansion project 1 into 800 megawatt supercritical thermal power plant, ultra supercritical.
দুর্গাপুর ফরেস্ট ডিভিশনে একটা প্রজেক্ট সাবমিট হয়েছিল গাছ কাটার জন্য নন ফরেস্ট এরিয়া আছে রিভিসির এখানে এটা অ্যাকচুয়ালি ওয়েস্ট বেঙ্গল ফরেস্ট প্রোটেকশন অ্যান্ড কনজারভেশন অফ ট্রিজ নন ফরেস্ট এরিয়া অ্যাক্ট 2006 রুল 2007 এর আন্ডারে পড়ে এই অনুযায়ী যদি এরকম কোনো নন ফরেস্ট এরিয়াতে গাছ কাটার জন্য কোনো ডেভেলপমেন্ট প্রজেক্টে পারমিশন চাওয়া হয় তো তার একটা বেসিক ক্রাইটেরিয়া হচ্ছে 5 গুণ ট্রি প্ল্যান্টেশন আগে করতে হয় তো এই প্রক্রিয়া চলতে চলতে এর মাঝে বিভিন্ন ডিসকাশনের সময় একটা মিটিংও করা হয় গাছ তো 5 গুণ লাগানো হবেই অতি অবশ্যই নিয়ম অনুযায়ী ঠিক আছে কিন্তু বেশ কিছু গাছ যদি ট্রান্সলোকেশনও করা যায় তাহলেও খুব ভালো হয় এই জন্য ডিবিসিকে তখনই ওই মিটিংয়ে প্রস্তাব দেওয়া হয় যে আপনারা এখানে मिनिमम 1000 गाछ ट्रांसलोकेशनों करबें।
हमारे हायर मैनेजमेंट ने तय किया कि हम लोग 1000 पेड़ को ट्रांसलोकेट करेंगे और उसी के अकॉर्डिंग हम लोग वर्क ऑर्डर प्लेस किए हैं और हमारा काम हो रहा है। In Durgapur project, we have completed the translocation of 10550 trees, around 1050 trees. We have completed the entire job within the 40 days of time span. The survivability rate is 85%. It is remarkably very much a good figure. In fact, in other stations, we can observe the around 70% of the survival rate. In our case, it is more than 90%. In spite of that, we are just considering the only 85%.
what is the importance and need of translocation? We have considered the three big factors for doing this job. One is the social requirement. We have a lot of sentimental trees and a lot of ritual trees are there. We should have to take care of that for getting the social acceptance. The social acceptance is very much required for expansion of the project. This is the one big reason. And the second reason is that environmental concerns. We are very much we are very much concerned about the biodiversity system and ecological balance. And apart from that, we are using these trees as a carbon sinks, carbon sequestration, and urban heat to resist the urban heat islands. Moreover, it will give the third reason is aesthetic look and a beautification of the plant also. We are consider this project. Major factors to consider before the translocation: we will assess the health and structural condition of the trees, species sustainable for the translocation, tree size and age, height and diameter, environmental conditions, engineering feasibility, cost effectiveness. We have considered these all the parameters before taking up this project. Major 5 methods are involved over there. One is the preparation of the trees. Second one is pruning of the trees, root ball preparation, lifting and transportation. And the fifth one is preparation of receptor sites and planting. During the process of preparedness of the trees, there could be 3 big steps. One is the enumeration and identification. We should have to earmark the trees which we are going to translocate, and we have to make a proper marking for that. We need to have a health assessment of the trees which can able to sustain after translocation. And moreover, the direction of the marking. We have to just to start the marking from the north side. The same orientation should be maintained after translocation of the trees. The next process is pruning of the trees. The tree shape, retention, removal of the unwanted branches, and retention of the young branches. There could be use of sharp tools and wound dressing. The wound dressing is a very much essential step. We should have to protect the trees for moisture retention as well as to avoid the fungal infection to the trees. We should have to take care as like a human being. Next step is root ball preparation. We should have to do this job on the stage by stage basis. First of all, we should have to remove the child roots first, and then after we go for the parental root. The root ball size should be, we have to consider approx 1.5 dia. There is the burlapping is the big step where we have to just use that wet kind of jute to retain the moisture during the translocation process. The next process is lifting and transportation. During this process, there is a big steps of selection of the cranes, lifting process, and transportation. We should avoid the injuries of the trees during the transportation process. Preparation of the receptor site, we have to check out the soil preparation, plantation orientation, backfilling, air pocketing and removal, and use of cow dung for easy retention of the nutrients. Challenges in the tree translocation, in spite of a lot of advantages, there could be practical issues are there, high operational and maintenance cost, and risk of transportation, shock, root damage during the excavation, transportation difficulties, dependence on proper post-transplant care. Factors affecting the survival rate: health condition of the tree, timing of the translocation, quality of the root ball preparation, climate condition, and soil quality. Environmental benefits. Tree translocation offers several environmental benefits: conservation of mature trees, reduction in the carbon emission, preservation of the biodiversity, improvement of urban air quality, reduction of urban heat island, ecological continuity in development projects. Conclusion: With improved technology and awareness, tree translocation can become an important tool for maintaining the ecological balance in rapidly urbanization regions. We should take care of the technical upgradation so that we have to maintain the cost effectiveness. These are the stage by stage process, so we have just kept over here as a pictorial view. Thank you, everyone.
Hello. Hello. First of all, it was a very nice presentation, and this was done for the first time, and it is a very good learning. We have to preserve the nature and go on with the development. And very nice work with the team EMPC and team DTPS. Best wishes for future endeavor. In next plant also keep the same spirit. In Chandrapura.
Can we explore this process for our as-dike reinforcement?
Sir, few of the projects are in pipeline, sir. We are going to do the 500 trees translocation in the Durgapur itself in the second phase, and later to that we are going to Mejia.
Yeah.
Yes, sir. Chandrapura also subsequent one.
Very green place, Chandrapura.
Yes, sir. Yes, sir.
Thank you very much, Venkatesh. Please stay on the stage. I would request our esteemed juries to kindly felicitate Mr. Venkatesh. This was really a unique project, and it ensures sustainable nature by translocation of trees from one place to another. And now we move on to another very interesting topic, which is leveraging digital twin outputs via SAP integration in DVC. And to present this, we have Srimati Smita Kundu and Srimati Sarmistha Sinha from ERP HQ, Damodar Valley Corporation.
Good afternoon, everybody. It has been a pleasure to be here today. Myself, Mr. Sinha, along with Smita Kundu, we are here today to deliver our presentation regarding leveraging digital twin outputs via SAP integration in DVC. We all know that India has several aging coal-fired thermal power plants, among which many belongs to Damodar Valley Corporation also. In these aging power plants, there are several issues due to equipment degradation, rising maintenance cost, and unplanned outages. To overcome these issues, DVC has already initiated the deployment of digital twin technology for real-time condition monitoring and remaining useful life estimation for critical equipments. DVC also has a strong enterprise backbone, that is SAP S/4HANA ERP system. Our target is to bridge these two technologies, that is integrating the outputs of digital twin with the SAP PM and MM modules. This enables condition-based decision making across maintenance and material management functions. From digital twin, we get the real-time condition about the equipment, and it also predicts possible failures. When these outputs are integrated into the SAP PM and MM module, it helps in predictive and automated maintenance scheduling, condition-based spare parts planning, improved plant availability through avoiding unplanned outages, reduction in working capital tied up in inventory, and dynamic inventory optimization based on asset health. Now, we will move to the mathematical framework. Suppose we have a equipment I, and for this equipment I, we get the expected remaining useful life, mu I, and the variance of uncertainty, that is sigma I square. This from the digital twin. This variance is due to the uncertainty in plant load, environmental conditions, wear and tear, etc. So, with these, we now want to model the failure probability for the equipment I. We use Weibull distribution for this, which is based on the survival analysis technique. Here, beta and eta are the shape and scale parameters for this function. We explicitly use the Weibull distribution because it fits most of the mechanical equipments and it covers nonlinear degradation also. So, using the Weibull distribution, we can estimate the lead time probability of failure during the lead time. Here, what is the lead time? Here, lead time is the total time required for the entire procurement process. Now, from this probability of failure, we can estimate the expected demand during the lead time driven by failures. And then we can optimize the reorder point using the safety stock concept, and with the help of EOQ principle, we can estimate the optimal order quantity. This is all the mathematical calculations, and it is given in details in our paper. Now, from our project, we get the reorder point and optimal order quantity. So, when the stock reaches the threshold value of the reorder point, it will automatically trigger the procurement process in the MM module of SAP. Again, from the optimal order quantity, it helps to procure the exact quantity in the MM module. Again, from this project, we get the probability of failure and remaining useful life. So, these are integrated into the PM module where it helps in maintenance planning and work order scheduling. Now, Simita will continue with the next slides.
Thank you, Shormishta Di. So, now we are coming to the architecture of our project. We have a physical layer where we have all the plant equipments, and from there we are collecting their data with the help of different sensors. Now this data is being fed into the digital twin layer, and in which we can the calculation of expected ROI and the sigma square is being done. Now these calculations, mu and sigma square, they are being fed to an analytical layer where we are doing our calculation. So in this layer, we are calculating the probability of failure within the lead time. After that, we are calculating the expected demand, and we are finally calculating the optimal order quantity and optimal order point. So after that, these calculated data, they are being fed into our already existing SAP ERP with the help of the API or middleware. And depending on the value of this data, different activities are being triggered into the SAP. So for this, we need the analytical layer in between, because we have already SAP and we have already the digital twin. So we are making the analytical layer, and with the help of API, we are getting the data in the SAP. So in this analytical layer, we are requiring an application server and database layer and network, etc. So we have done a case study regarding this. Boiler tube leakage is a big issue in our plants, we all know. And we have a case study on, on this boiler tube leakage with our project. So we have used a semi-synthetic data for our project because some of the data that is easily available with us, we have taken those data, and some of the data that is not directly available with us, we are assuming some value for them depending on different papers, etc. So we can see that we have assumed actually that we have 50 critical tubes and the RUL for them are 10 to 30 days and the lead time is 10 to 20 days. With this, with our calculation, we can get that there is a 36% failure probability within the lead time. Almost 18 tubes are expected to fail, and if we are following the traditional fixed reorder policies, we may miss these failure things. So with our condition-based approach, we can see that our reorder point is 25 units, and our reorder quantity should be 27 units. So we have simulated our total system in like Python, and we have found there is a forced outage rejection of 30 to 40%. Our emergency procurement has been cut from 50 to 60% because we have conditions-based planning, and our inventory is optimized from 20 to 25%, and the spare availability obviously increased. So in conclusion, we can see that we already have two big pillars, the SAP ERP and the digital twin with us. We are just placing the bridge between them. So we are getting the best usage of these two pillars. And this system is too much scalable in our DVC family because we think that we need really very minimal like hardware things and minimum things to implement in our like DVC to establish this. And finally, we can see that our adaptive decision making is like helping us for dynamic safety stock and reorder point adjustment automatically to change asset health conditions. We also have financial benefits through proper stock management and timely procurement plans. So digital twin integration provides a practical roadmap for legacy thermal power plants to achieve reliability improvement, cost reduction, and extended asset life cycle through intelligent closed-loop asset management. These are some references, and if you have any question, please welcome. Thank you.
It was a very good presentation and a nicely presented. If the thing becomes successful, it will be a game changer for DVC in future.
Truly, sir, truly.
It will be a game changer, and because we have to optimize the costs and increase the reliability.
Yes, sir.
Thank you.
Thank you, sir. Thank you.
Any questions from the audience? Thank you, team. I request the esteemed session judges to felicitate Shimita Kundu and Sharmishta Sinha from Damodar Valley Corporation, Enterprise Resource Planning Cell. Please give a big round of applause for the presentation of Shimita Kundu and Sharmishta Sinha. Thank you. Our next presentation is on the topic Enhancing Thermal Power Plant Reliability Through Root Cause Analysis and Predictive Maintenance Practice, a case study approach. And to present this, I would like to invite upon the dais Mr. Prabhakar, Mr. Shubhadeep De, Mr. Mantosh Raj, and Srimati Priyanka. The team is from Kodarma Thermal Power Station, Damodar Valley Corporation.
Very good evening, sir. We, electrical maintenance team of KTPS, is here to present few upgradation and rectification through root cause analysis and predictive maintenance to enhance power plant reliability. Sudip, please.
Thank you, sir. An unit tripping during peak hours resulted revenue loss of 1.13 crore for KTPS. If we consider the revival time of 2 hours only, our topic of discussion is how we can avoid this much huge revenue loss. Here we will discuss 4 real case study of KTPS that we faced, and the implemented solutions are simple yet effective to improve the system reliability. The first case is about a peculiar and unusual unit tripping. It was morning shift and time was around 7 a.m. when shift engineer started the DC GOP motor for trial run. And after completion of trial run, when they turned off the motor, unit got tripped suddenly due to tripping of most critical auxiliaries like both PF and FD fan. It was a very peculiar event, and the first cause was EPB operated. And along with that, multiple transformer feeder also got tripped. This condition arises several abnormal observations. The tripping was occurred during the DC GOP motor cutout only. There was no problem during motor starting or running condition. And also simultaneously tripping of multiple feeder took place. So it indicates a common influencing factor may be the reason. So we identified it as 220 volt DC system because it was linking all the systems. During root cause analysis, we studied the relay DR, and we found the relay has generated the trip command for the feeders because of false binary input pulses of emergency push button and winding temperature indicator. But the pulse duration was very short, 18 to 25 milliseconds. And after that, we also checked the motor. We found interpole, shunt field, series field. All IR value was okay, and motor parameters were absolutely okay, but its armature has critically low IR value. And we also check the C1 conductor timing test, and it was in order. Now let us see what was the actual reason because the tripping occurred. We all know inductor doesn't allow sudden change in current. But when we are turning off this motor, because of opening of C1 conductor, through the series field, the current is changing from 280 amps to 0 amps within 75 milliseconds. Due to that, very high LDIDT transient voltage appear across the series field. And note that the armature is already grounded because of low IR value. So this high LDIDT transient voltage propagated to the 220 volt DC DB through the highlighted path. And it creates a sharp voltage profile shift with respect to ground within 75 milliseconds. And as we know, the EPB and WTI cables are long control cables. They have significant capacitance. So this sharp profile shift drives the relay binary inputs for the sharp duration, and due to that, tripping occurred. After that, to validate our intuition, we do MATLAB simulation, and we model 2 motors, one with low IR value, one with high, healthy IR value. And we found our simulation result as per our field findings. In the low IR value motor, there was clear spike of 90 volt within very short duration, but when we study the healthy IR value motor, that has no clear voltage spike. So we decided to change the motor and also introduce a filter timer of 100 milliseconds to reject the transient binary input pulses if such incident occur in future. Thus, we implemented a robust logic that make our system immune to the transient disturbances if future happenings there. So that was a scalable solution, and it was implemented across other plants of DVC also. Now coming to the second case study, it was 5th June 2025 when KTPS Unit 1 experienced an unexpected tripping that originated from booster fan motor. Actually, in this PT drop-down cable, there was a flashover. And due to that, UT standby earth fault protection relay at GRP operated, and due to that, unit trip in class A protection. So BTS initiates slow transfer, and during that process, booster fan motor experienced 19 kiloamps of fault current in its B phase. In that case, we were lucky enough that the motor did not get damaged during withstanding this much current. This arises several critical concerns. We do root cause analysis of all the concerns. First concern was, why did the flashover occur at all? These PT drop-down cables were oversized and its insulation capacity was underrated. When this cable come into contact with the grounded breaker frame, it causes a insulation stress, and due to that a flashover occurred that creates a direct earth fault on 1BB board. After resolving all the issues, we make the breaker ready. The second concern was, why did the faulty feeder not trip immediately? If there is any fault, the breaker should trip. But we all know CT is the eye of a protection system. After CT, this is the zone where the protection system acts. But the fault was within the circuit breaker. So it was in the blind zone for the protection system. This was most critical concern. How did this motor experience so much high current? Actually, in the board, there was already a earth fault that was persisting because of the flashover. So BTS cannot execute fast transfer. It execute or initiate slow transfer. In that process, the booster fan circuit breaker was already in on condition and motor was slowing down. Due to that, decaying motor back EMF was present during re-energization through the station tie. Now, the station tie and motor bus has different phase angle, different frequency. So this creates severe out of phase or asynchronous charging. And for that reason, 19 kilo amps through current flow through the motor. And we also observe a thermal heating mark at the B phase terminal. The last concern was, how did the motor remain connected during BTS slow transfer? Actually, BTS always provide a trip command to the drives connected to the bus, especially the motor feeders. But in that case, it was a retrofitted scheme. In there, no trip command was there. So we do a modification in the BTS logic, and we assign trip command for the remaining booster fans. And with that, we are confident enough that we will be able to prevent future failure, catastrophic failure of this large HT motors. Now coming to the third case study, we all know 24-volt DC system is the heart of max DNA system. And any loss or disturbance might lead to unit tripping also. But in the existing configuration from inception, there were 4 battery chargers for BOP and 4 for SGTG, but only 2 AC sources were available, and each source feed 2 chargers. So if there is a failure of one AC source, that could lead to outage of 2 chargers. So it's a vulnerable condition. So there is a redundancy that exists at the charger level, but not at the source level. As a corrective action, we provide independent AC source to chargers, and supply were distributed in such a way, some from unit board, some from station board, so that common source dependency can be avoided. With that, we gain high system reliability with the simple modification that involve minimum implementation cost because it only needs the cost of the cables. And we also make our system resilient against any upstream AC disturbances, thus reduce the unit tripping risk also. The last case is about acoustic condition monitoring. Actually, from last 2 to 3 years, we are facing occasional motor failure case in spite of regular conventional checking. The condition became more serious when KTPS Unit 1 got tripped due to bearing failure case of MDBP AOP. There are several other critical auxiliaries also, and this kind of failure was a direct compromise to our unit reliability. Actually, for drives up to 75 kilowatt, those are protected with thermal overload relay, and it's work on the basis of thermal expansion of this bimetallic strip. So it needs certain time to operate. And this kind of undetected bearing faults lead to bearing seizure within very short period of time. That creates a lock rotor condition, and due to that, winding failure took place, and earth fault also may be there. That leads to unit tripping. It was the case of MDBP AOP. To tackle this situation, we start a predictive monitoring technique. We use ultrapower 10,000 to monitor ultrasonic dB levels. And along with that, we also started daily thermography of the critical motors. Actually, this instrument measures ultrasonic sounds of the bearings with minor defects and convert it into audible sound so that we can detect the faults at earlier stage. After implementation of this practice, within 2 to 3 months, we get the result. During routine checkup of primary water pump 2A, we found there is a dB level raise from 30 to 46 dB, although there was no other abnormality in terms of bearing temperature or any abnormal sound in audible range. So we took shutdown of the motor and we changed the bearing and also make this drive available. When we analyze the replaced bearing, we find there is a deformation in one of the balls. So if this kind of bearing defect remain undetected, it would lead to winding failure. After this implementation, we found significant reduction in such bearing failure cases where we are conducting this practice. And also maintenance cost has reduced because we are just replacing the bearings before failure of the motor, that renew the complete motor repair. So these were 4 case studies where our implemented solution can be implemented in other installation also to improve system reliability so that we can avoid this kind of huge revenue loss due to unit outage. Thank you.
वेरी गुड, एक्सेलेंट एक्सेलेंट। इसमें हम पूछना है कि डीसी बैटरी जो है था, बैटरी सिस्टम था, उसके रिडंडेंसी के लिए क्या कर रहे हो?
डीसी
उसको प्रोक्योरमेंट के लिए सेकेंड सोर्स लगाने का ऑर्डर दिए, इंडेंट किए? नहीं नहीं नहीं, डीसी बैटरी सिस्टम की बात जो कर 24
इंडिपेंडेंट सोर्स आर अवेलेबल देयर ना। उसका सर
नहीं नहीं, दो चार्जर 4 गो था, 2 सोर्स था।
चार्जर था सर,
एक सोर्स 2 चार्जर को दे रहा था।
एक सोर्स को 2 चार्जर में लूप कर दिया था।
हाँ,
इनिशियली वो ऐसा ही चल रहा था। लास्ट टाइम जो यूनिट 2 का ओवरऑलिंग था उसमें हम लोग कर लिए थे केबल्स डाल करके, इस बार यूनिट 1 के ओवरऑलिंग में भी यूनिट 1 में कर लिए।
एक चार्जर इंडिविजुअल बैटरी को ले रहा है क्या?
नहीं सर, दो चार्जर
एक बैटरी बैंक,
एक बैटरी बैंक 2 चार्जर के लिए है।
हाँ, एक बैटरी बैंक के लिए 2 चार्जर है।
अच्छा, ठीक 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 है, ठीक है। नहीं मतलब ये सर्कुलेट हुआ पूरे डीबीसी ऑल द वैली पूरा सर्कुलेट हो गया?
ये तो सर हम लोगों के पास इशू था, केटीपीएस में ऐसा इशू था, दूसरे जगह ऐसा इशू है कि नहीं?
दिस एनालिसिस शुड बी सर्कुलेटेड टू एवरीबॉडी, और सब स्टेशन में इस ढंग का एनालिसिस होना चाहिए जिससे कि रिलायबिलिटी टू द इक्विपमेंट बढ़ेगा, ठीक है ना?
सर चार्जर लेवल पे रिडंडेंसी था, लेकिन ये एसी सोर्स के चलते मतलब 400 रिडंडेंसी का जो जरूरत था उसके जगह पे 200 अवेलेबल था।
समझ गए।
तो ये 400 अभी कंप्लीट है, कोई भी एसी सोर्स फेलियर
तो
होगा
ये
तो
मॉडिफिकेशन दूसरे स्टेशन सब 500 में होगा ना ऐसा?
जी जी सर।
और मॉडिफिकेशन सब जगह हो गया? हाँ हाँ, नहीं जो भी है इसको इम्प्लीमेंट करना चाहिए हर एक जगह। यदि ऐसा है तो एक बार ऑडिट सर, एक बार
से शेयर कर देंगे।
एक बार ऑडिट करा दीजिए सपन, एक बार ऑडिट करा दूँ, ठीक है? वेरी गुड, वेरी गुड, वेरी नाइस।
ठीक, it was a nice presentation and a very small investment में if these things are being done, they will definitely have a huge impact on the revenue. Thank you very much.
एक्चुअली मैं ये बोलना चाहूँगा कि ये जो एनालिसिस है ना, ये करते रहिए।
जी सर।
दिस इज एप्लीकेबल फॉर ऑल द प्लांट्स। ये हम लोग करेंगे, एनालिसिस करेंगे, तब जाके हम लोगों ने रूट कॉज फाइंड आउट करेंगे और उसको रूट आउट करेंगे। एक्सीलेंट
सर। DCGOP केस वाज मोस्टली पिक्यूलियर सिचुएशन दैट वी फेस्ड, सो वो एनालिसिस करके हम लोगों को भी एक सेटिस्फैक्शन मिला, कुछ काम हुआ उसमें।
Thank you very much, Team KTPS, for this beautiful presentation. And now I would request our esteemed session judges to kindly felicitate the Team KTPS. Huge round of applause, ladies and gentlemen. And now, as we are running slightly tight on the schedule, we will be having some quick presentations by our DVC personals. And for the first presentation, I am going to invite Sri Ranju Sarkar, Sri Krishlaya Kumar, Sri Pushkar Chand, and they will be presenting on topic driving sustainability and reliability.
सर आपका ये वाला है ना प्रेजेंटेशन? नहीं नहीं, इसमें से कौन सा है? सेकंड वाला ये वाला है ना? ये वाला है पॉइंट।
Good evening, sir. Respected member technical sir, respected delegates, and respected EDs and presented audiences. I, Sri Ranju Sarkar, Senior Manager, along with my colleague, Sri Kishlay Kumar, Manager, and Sri Pushkar Anand, Manager, presenting here the driving sustainability and reliability. MTPS is the largest power station in the eastern region of India, having thermal capacity of 2,340 megawatt, comprising of 400 to 4 into 210 megawatt and 2 into 250 megawatt and 2 into 500 megawatt. Unit 1, first unit 210 megawatt came into operation, commercial operation on December 1997. Since then, more than 20 years have gone and in servicing, and it generated 1,463.59 million units in the last financial year. And it is the highest capacity, declared capacity is 96.38% since 2020-21, and all-time highest the Unit 5 250 megawatt, it is the 97.06%. Most challenging part is the 40% capacity in 500 megawatt, minimum load is 200 megawatt within 4 hours, running within 4 hours without oil support. The next, sir, the automatic generation control, which gives us the revenue of 2.5 crore the last year. It is the implemented in Unit 7 and 8, which is the dynamic grid responses, balancing the grid with reliability of demand and generation. Next, sir, operational opportunities highlights. It's also in Unit 1, 79.56% PLF achieved in 2000, since 2010 and 11 in the last year. Now the Unit 5 and 6 rooms are unified and reduced manpower redundancy and improved monitoring. Continuous 4-hour oil-free running of minimum load of unit in 200 megawatt. Next, sir, the heat rate. Actually, PAT cycle performance action trade, it is last year, after completion of monitoring and audit by the M-Panel Agency of Bureau of Energy and Efficiency and compliance submitted, we have achieved 34,468 certificates, which almost equivalent to 7.5 crore of MTBC DVC achieved. And the hit rate was target was that the net hit rate is 2,579.68 kilocalorie per kilowatt hour, achieved 2,550.30 kilowatt hour. So improvement was 29.3. That's how we achieved 34,468 certificates. So main optimization process in refinement, bond efficiency, and reduces boiler losses. Turbine efficiency, we in Unit 3 and Unit 8, we changes the HPT module, so turbine improve the HPT efficiency, which reduces the heat rate. Auxiliary power consumption, in Unit 5 and 6, 3 CW pumps are running, mostly in the winter season. Previously it runs 4 pumps, so it reduces the APC. Similarly, it's enhancing the control system by real-time monitoring the critical parameters. Next, I hand over to the next person, Pushkar.
Thank you, sir, for setting the tone of the presentation. Due to paucity of time, I will quickly go through the slides superficially. So talking about environmental management and sustainability, MTPS has shown strong commitment for emission controls. FGD system for Unit 1 and 6, Block 1 was completed in this financial year and gypsum was generated. Also, DNOx system for Unit 4 was commissioned and PG test was completed and NOx emissions were reduced for Unit 4. ESP augmentation for Unit 3 is already in progress. First pass has been completed and second phase is also in progress, and SPMs are maintained well below the regulatory norms. Talking about resource utilization and byproduct management, this financial year saw 42,000 metric tons of gypsum sales, which generated revenue of about 4.43 crore for MTPS. Also, dry fly ash evacuation system, 12.99 lakh metric tons were evacuated, which generated revenue of about 13 crores for MTPS. 15.83 lakh metric tons of coal was sourced from Tubaid mines. The The first two achievements show economic circular leadership for MTPS, where waste generated from process is used as a raw material for another industry. And the third achievement shows operational supply chain resilience and independence for MTPS. So moving on to financial performance and cost optimization, AGC incentive earned for this financial year was 2.51 crores for unit 7 and 8. This is apart from the energy charge. This is just the incentive, which is about 50 paise per kilowatt hour for the average generation in APC. We also saw COC improvement for unit 7 and 8. COC improved from 3.4 to 4.0. This significantly reduced the water consumption, and chemical usage was also optimized. Also, scrap sales and recovery from NHAI also saw significant revenue generation for MTPS. Control system modernization and automation was also achieved in MTPS. Due to the paucity of time, I would like Kisle sir to conclude the slides.
Thank you, Pushkar. Transition from PAT cycle to CCTS, a strategic requirement for MTPS. For major thermal power station, which has already demonstrated a strong performance under PAT, a proactive and structured transition approach towards CCTS is essential to sustain competitiveness, regulatory compliance, and financial performance. MTPS has established a solid base through its achievements in PAT Cycle 7. About CCTS, CCTS establishes two distinct pathways, compliance mechanism and offset mechanism. MTPS must therefore transition from pure efficiency-driven approach to a carbon-centric operational strategy. MTPS is well positioned for this transition due to several ongoing initiatives like improved heat rate performance under PAT, reduced specific coal consumption through coal yard management, APC reduction through optimized equipment operation. Now, concluding part, overall MTPS is well positioned for future challenges, particularly the transition from PAT to CCTS with a solid foundation in efficiency monitoring system and sustainable practices, ensuring continued operational excellence and regulatory readiness. Thank you, sir.
In the present scenario, in solar hour, our power cost is very less. Sometimes it comes up to 0 paisa, free power. So whether we can run our 500 megawatt units in solar hour at 200 megawatt load, 40%. And in any combination of coal, that will help us from commercial point of view.
Sir, the testing has already been done. The testing was done for 4 hours, and 200 megawatt unit, 500 megawatt unit was run for 4 hours without oil support, and with ABCD combination, with
So
ABCD elevation.
Can we
But
do it every day?
24-hour operation has still now not been tested.
Only in the solar hour.
Sir, it has
Can it be
already
possible?
been tested. It can be done.
Actually, process is refined further. It can be improved. For more 4 to 8 hours, it can be.
Then actually the solar on sustainable basis, whether this can run on sustainable basis without any impact on any failure to the equipment.
Actually, sir, after implementation of EPC, Advanced Process Control, that may be, if it is efficiently implemented, that can be achieved, I think.
Okay, that will be helpful for the grid also in future. ठीक, okay.
Any questions from the audience? Okay, thank you. I request the esteemed session judges to felicitate the presenters with tokens of appreciation on behalf of Damodar Valley Corporation. Ladies and gentlemen at the back, please stay back and enjoy our presentations. These people have come from near and far to enrich our conference with their valuable research work, so please stay back. Please give a round of applause for the presenters. Thank you once again, team. I would like to request that there is a QR code card on everyone's table. Please scan the QR code and put in your valuable suggestions and feedbacks. Our next presentation is on the topic installation and commissioning of new coal mill reject silo or bunker at Raghunathpur Thermal Power Station, Damodar Valley Corporation. Please put in a round of applause as I invite the speakers on the dais. Mr. Shumanto Mondol, DGM, Raghunathpur Thermal Power Station. Mr. Rishikesh Kumar, Executive Mechanical, Raghunathpur Thermal Power Station, with his team. Sir, please. Please welcome our participants, our presenters, as they present us with their new work.
Good afternoon, respected member technical subs, respected seniors, respected judges, and my dear colleagues. It's a great pleasure for us to be here to present our work, installation and commissioning of new coal mill reject silo or bunker at RTPS DVC. This presentation is based on real operational challenges encountered at our plant and the steps we have taken to overcome the problems like maintenance reliability, improvement operation efficiency, and system reliability. I look forward for your feedback and discussion after the presentation. Thank you. Let us start. May I request Mr. Pankaj Kumar to...
Thank you, Sumanto sir. Now I will explain how this system works and why this bunker is required for mill reject system. At RTPS, 2 units of 600 megawatt are installed. In each unit, 8 coal mills are installed for pulverizing of raw coal. The ungrounded portion of coal is automatically diverted to the mill reject system and collected in the respective pyrite hopper. And later, this reject material will convey pneumatically to the common bunker or silo through individual pipeline. Initially, 2 mill reject silos were shared between the 2 units, leading to extensive pipeline runs and inefficient convenience, and requires high pressure to convey the mill reject. So, in this system, we have some limitations. Several operational challenges were observed in the earlier configuration. Due to the long conveying distance, the pipeline developed multiple leakage points, which leads to more maintenance work and surrounding area untidy. Also, this pipeline runs over the critical equipment like PFN and FD fan. So reject material often fell over critical equipment such as PF and FD fan, contaminating lubricating oil tank, and in some cases damaging fan blades. Also, due to long run of pipe, during full load of operation, we have need to run 3 compressor to convey the mill rejects. So, we have decided to eliminate these inefficiencies. We have installed a new mill reject silo between the 2 units. The objective were shorten the conveying distance, reduce pipeline wear and leakages, minimize energy consumption, enhance system reliability and safety. A rented silo structure was arranged from RTPS Phase 1 batching plant site and refurbished for use. This is a picture of old silo. This was the cut from the old batching plant. And then a local contract was awarded to execute this job. This is some picture of fabrication and installation of new bunkers. This is the final picture of new bunker, where mill reject collected. Technical implementation. After installation of this bunker, conveying pipe length reduced from 1200 meter to 400 meter. Eliminate one compressor from 3 to 2 during full load operation. And due to less pipe length, we have to convey only 30 seconds to convey the reject material. Earlier it was in 60 seconds. In this way, the total investment cost is 28 lakh for a local contract. Material saving, reduction in 125 NV mild steel pipe length by approximately 800 meter, resulting in, if it will cost, and 13 lakh we will save. Power saving. Due to the shorten the conveying distance, we have required less conveying air pressure to transport the mill reject, and one compressor in ideal spare condition. In this way, we have saved 53 kilowatt in one compressor. Total monetary saving is 4,000 per day, and for 1 year it is around 15 lakh. Total annual saving is around 27 lakh, and payback period is approx 1 year. Result and discussion. Due to installation of new bunker, reduction in compressor usage from 3 to 2, lower energy consumption and maintenance cost, minimize leakage and pipe erosion, improve safety condition around PFN and FD-fan area, enhance system reliability and cleanness in the mill area. The in-house initiative to install a new mill reject silo at RTP successfully mitigate operational inefficiencies associated with the earlier setup. The project achieved a payback period of approximately 1 year, demonstrate both technical and economic viability. The project underscores the value of resource optimization, innovation in reuse of ideal infrastructure, and collaborative engineering within the Dvc project. The team extends sincere gratitude to Sri PLSS Chaitanya Prakash PD project sir, Sri R.K. Syamal sir, Sri Abhijit Ghosh sir, Sri Somnath Sarkar sir, and Sri Vinod Behra sir for their continuous gratitude, support, and encouragement during this project. Thank you, sir.
This was a very good initiative taken from RTPS. I think such type of initiative may be taken by other plants also, which is very utilizing the old resources and getting good benefits.
Yes.
Well done.
No others material we have purchased, sir. Only the rejected.
You have used the old material.
Yes,
only
sir.
the works that I was that one.
Yes, sir. Thank you, sir. Thank you, sir.
Please come on the stage. I would request our esteemed judges to kindly felicitate the team. Thank you very much. And the last presentation for the day is by Manish Kumar on the topic reliability centered maintenance.
Hello, good evening, sir. My presentation is reliability centered and maintenance. From reactive breakdown system reliability. पहले क्या होता था सर कि मैं हिंदी में कन्वर्सेशन करूँगा, किसी कोई दिक्कत तो नहीं सर? पहले क्या होता था कि पहले हम लोग देखते थे कि मिल में जो प्रॉब्लम आता था उसके पहले ही हम लोग देख लेते हैं क्या प्रॉब्लम आने वाला है। इसका मतलब फ्रॉम रिएक्टिव ब्रेकडाउन सिस्टम रिलायबिलिटी, पहले हम देख ले रहे हैं कि क्या प्रॉब्लम आने वाला है, उसके हिसाब से हम लोग परमिट ले लेते हैं और उसका जो भी प्रिवेंटिव करना होता है वो हम लोग कर लेते हैं इसमें। सेकंड स्लाइड। पहले क्या था सर 1 to 8 में कि बिफोर कोई आइसोलेशन का प्रोविज़न नहीं था मेरे पास पंप में। कुछ समय के बाद हम लोग देखिए कि एक भी मिल में प्रॉब्लम आता था पंप में तो हम लोग को मिल बंद करना पड़ता था, फिर मिल चेंज ओवर करना पड़ता था। तो उसके लिए हम लोग हर मिल में ये प्रोविज़न किए कि HP पंप में एक सक्शन वाल्व जो सक्शन था उसमें एक अलग से हम लोग आइसोलेशन वाल्व का प्रोविज़न किए ताकि मिल चलता भी रहे तो हम लोग को मिल को बंद नहीं करना पड़े और दूसरा पंप को आइसोलेट करके उसमें हम लोग काम कर सकते हैं। इसलिए हमारा मिल को चेंज ओवर करने का जो पोजीशन था वो धीरे धीरे हमारा घट गया। थर्ड स्लाइड। पहले का था फ्रीक्वेंट लो ऑयल प्रेशर लो एंड प्रेशर हंटिंग। अब सर मेरा प्रेशर हमेशा कोई हंटिंग नहीं होता, हमेशा प्रेशर मेरा एबव 30-40 kg मेंटेन रहता है। फ्रीक्वेंट HP पंप रिप्लेसमेंट, पहले हमेशा हमको HP पंप रिप्लेसमेंट करना पड़ता था। आज के टाइम पे सर हम एक भी मिल में 1 to 6 में एक भी HP पंप एक लगभग 1 ईयर में 1-2 रिप्लेस किए हैं। MS पाइपिंग विद कन्वेंशनल फेरूल फिटिंग एंड सिंस कमीशनिंग। फेरूल फिटिंग और एसोसिएटेड विद डाउन टाइम एलिमिनेटेड। फेरूल लीकेज सर मिनिमाइज हो गया और हम लोग उसको मिनिमम टाइम में हम लोग उसको अटेंड कर लेते हैं। रिपीटेड लीकेज वायल वेस्टेज एंड अनप्लान्ड शट डाउन। लूब ऑयल कंजम्पशन स्मूथली रिड्यूस हुआ है। इसके चलते पहले जो हमें हमेशा तेल टॉपअप करना पड़ता लीकेज होने से, आज के डेट में वायल टॉपअप मिल में मिनिमम से मिनिमम हो गया है। एक बार सिर्फ हम लोग जब मिल मतलब 1 ईयर में एक बार पूरा वायल क्लीन कर लेते हैं और वायल टॉपअप करते हैं, उसके बाद हमको मिल में वायल टॉपअप करने का पोजिशन नहीं के बराबर है सर 1 to 6। Lube oil tank serve only reactively after visual problem. Continuous purification of lube oil during live operation. ये continuous purification मतलब हम सेंट्रीफ्यूज लगा दिए। 1 to 6 में सारे मिल में सेंट्रीफ्यूज है, तो सारा मिल में सेंट्रीफ्यूज चलता है तो लूब ऑयल प्यूरिफिकेशन को पूरा क्लियर रखता है। मतलब कभी भी हमारा वायल से लीकेज का जो चांसेस था वो हमारा धीरे धीरे बंद हो गया। इसके चलते मिल चेंज ओवर करने का नौबत तब नहीं रहता है। कंटामिनेंट एक्यूमुलेटेड इन टैंक डिग्रेडिंग वायल क्वालिटी। वायल किलनेस एंड क्वालिटी मार्केटेबल इम्प्रूव। सेंट्रीफ्यूज चलाने से हमारा वायल का जो क्वालिटी था मार्केटली इम्प्रूव कर गया। नो कंटिन्यूस प्यूरिफिकेशन मैकेनिज्म इन प्लेस। HP पंप एंड बॉल एंड सॉकेट पंप फेलवर स्पेशली रिड्यूस। अब हमारा जो सेंट्रीफ्यूज चलाने से या कंटिन्यूस वायल लेवल मतलब कोल्ड डस्ट जो भी लीकेज होता था, आज के डेट में सर 0 लीकेज है 1 to 6 मिल में। इसलिए हमारा वायल में कोई भी कोल्ड डस्ट कंटेमिनेशन नहीं है। तो कोई जब कंटामिनेशन नहीं है सर तो हमको पंप चेंज करने का नौबत तब नहीं है। जो पंप लगा है 1 साल से कंटिन्यूस चल रहा है। एक एसोलेटेड व्यू ऑफ HP पंप एंड बॉल एंड सॉकेट पंप। टैंक क्लीनिंग हम लोग एवरी 6 to 8 मंथ में सर एक बार टैंक क्लीन कर लेते हैं, वायल को चेंज भी कर लेते हैं जरूरत पड़ने पे। रेसिडुअल ग्रीस टैग 40 एक्यूमुलेटिंग इन ड्रेन चैम्बर। पहले क्या होता था सर, इसका केस स्टडी ये है कि हमारा रिड्यूसर गियर बॉक्स हमेशा मेरा ब्रेकडाउन होता था। रिड्यूसर गियर बॉक्स रिड्यूसर पंप, तो हम लोग देखे कि ऐसा हो क्यों रहा है। तो देखिए उसका ड्रेन चैम्बर एक कप खोले, ड्रेन चैम्बर खोलने के बाद देखिए उसमें पूरा ग्रीस भरा हुआ है। जब वो ग्रीस को धीरे धीरे करके पूरा निकालने के बाद उसका मैनुअल पढ़े, मैनुअल बोला है ड्रेन चैम्बर 100% क्लीन रहना चाहिए। ड्रेन चैम्बर जब 100% क्लीन कराएं और उसका टीथ जितना भी है 222 टीथ है गर्थ ईयर का, पूरा टीथ 100% क्लीन हो गया। तो देखिए हमारा जो वाइब्रेशन आता था गियर बॉक्स में वो आज के डेट में सर 0 हो गया। 1 to 6 कोल मिल 1 to 6 में एक भी गियर बॉक्स 1 साल से ट्रिप नहीं हुआ है सर, फेलुअर नहीं हुआ है। सर जीरो ग्रीस डिपॉजिट ऑन गियर टीथ, मतलब जीरो है आज के डेट में। ड्राइव शाफ्ट, दूसरा है सर ड्राइव शाफ्ट वाइब्रेशन, गियर कपलिंग ब्रेकेज, एक्सीलरेटेड गियर। पहले हमारा अक्सर मिल में सर वाइब्रेशन आने से गियर कपलिंग मिल का जो था गियर बॉक्स का वो हमेशा ब्रेकडाउन होता था। आज के डेट में सर लास्ट 10th मंथ में एक भी गियर कपलिंग मेरा ब्रेकडाउन नहीं हुआ है। इसका रीज़न ये है सर कि हर 3 महीना पे हम लोग जो भी गियर कपलिंग है उसको हम लोग ग्रीसिंग करते हैं, खोलते हैं, और एवरी PMS में उसको हम लोग चेक करते हैं थ्रू प्रॉपरली, उसका बोल्टिंग चेक करते हैं, और हर 3 महीना पे ग्रीसिंग जरूर करते हैं। तो ग्रीसिंग करने से मैनुअल में लिखता है कि एवरी 3 मंथ आपका गियर कपलिंग जो है उसको ग्रीसिंग करना है। ग्रीसिंग करने से हमारा गियर फेलुअर सर 0 हो गया। पहले बॉल स्क्रीनिंग, नो स्ट्रक्चरल बॉल स्क्रीनिंग शेड्यूल इन प्लेस। बॉल स्क्रीनिंग सर हम लोग अब अंडरसाइज बॉल एंड फॉर्जिन मटेरियल एक्यूमुलेटेड इनसाइड, पुअर कोल फाइनेस एंड हाई पॉल कंजम्पशन, इंक्रीज इंटरनल वियर ऑन मिल लाइनर पहले था। अब सर हम लोग बॉल स्क्रीनिंग जो है हर 6 से 7 हज़ार रनिंग आवर पे मिल का हम लोग बॉल स्क्रीनिंग कर देते हैं। बॉल स्क्रीनिंग में जो भी रेसिडुअल स्टोन है, जो भी फॉरेन मटेरियल वो निकल जाता है। निकलने से क्या था हमारा परफॉर्मेंस मिल का सर धीरे धीरे बहुत बढ़ गया, और हमारा एनर्जी मीटर भी 1.45 हमेशा रहता है। इससे हमारा मतलब APC में भी इम्प्रूवमेंट है सर, और मिल का ब्रेकडाउन धीरे धीरे घट गया। कोल फाइनेस एंड ग्राइंडिंग एफिशिएंसी, कोल फाइनेस भी सर हमारा मोर देन 1 to 4 80% के अप्रॉक्स रहता है, और 5-6 में मोर देन 70 के आसपास है सर, 70। मिल इंटरनल वियर रिड्यूस, स्टेबल कंसिस्टेंट ऑफ मिल ऑपरेशन अचीव्ड। Heavy dust accumulation on coal mill and feeder floor area. Before, poor housekeeping, unsafe, insufficient working condition, restricted accessibility of routine inspection and maintenance, hidden failure undetected due to poor visibility. आज के डेट में सर 1 to 6 में एट प्रेजेंट हमारे जो भी यहाँ प्रेजेंट और पास जो भी यहाँ रहे वहाँ सर HOP O&M उनके गाइडेंस में आज के डेट में पूरा कोल मिल एरिया 1 to 6 में कहीं भी सर कोल एक्यूमुलेटेड नहीं है, ना फीडर फ्लोर ना कोल मिल एरिया में, और कोल डस्ट पूरा 0 है सर। इससे सर हमारा बेटर फैसिलिटी ऑफ इंस्पेक्शन एंड मेंटेनेंस कर पाते हैं, हिडन फेलियर डिटेक्शन हम इम्प्रूव कर पाते हैं, जाके देख पाते हैं कि क्यों फेल हो रहा था। और जो क्लीन कोयला नहीं है सर तो हम नज़दीक से मेंटेनेंस ऑपरेशन दोनों सेक्शन जाता है, CNI सबको जाके देखते हैं, और उससे देखते हैं कि फेलियर का रीजन क्या है जो इजिली एक्सेसिबल हो गया। PMS activity not performed in a timely and systematic manner। अब है सर कि PMS की हर हम लोग 20 से 25 दिन में हम लोग PMS कर लेते हैं मिल का, एवरी 1 to 6 एवरी मिल का। एब्सेंस ऑफ स्ट्रक्चर शेड्यूलिंग लीड टू रिएक्टिव मेंटेनेंस, ईयरली डिटेक्शन कर लेते हैं सर पहले ही। मान लो कोई मिल में कुछ प्रॉब्लम आता है तो हम लोग ड्यूरिंग PMS के पहले डेली जो लोग मॉनिटर करते हैं, देखते हैं कि इसमें क्या प्रॉब्लम है। उससे हम लोग अपने O&M HOP साहब से बात करके मिल को परमिट ले लेते हैं, और ईयरली पहले मिल ब्रेकडाउन होने के पहले उसमें हम लोग काम कर लेते हैं, जिससे मतलब मिल ट्रिपिंग या मिल का ब्रेकडाउन हमारा सर धीरे धीरे इम्प्रूव किया, घटा है। Frequent unexpected breakdown, unplanned breakdown significantly reduced due to missed preventive action. Vibration level 12 to 16 mm per second at FAR 1.4। सर PFN 6B का केस था कि वो 2023 से उसमें वाइब्रेशन चल रहा था। लास्ट मतलब नवंबर 2025 में उसमें वाइब्रेशन बहुत ज़्यादा आ गया, फिर मिल को PFN को हम लोग ब्रेकडाउन करना पड़ा। उसमें फिर हम लोग काम किए सर, आज के डेट में वो वाइब्रेशन बिलो 2 mm per second है। HP pump changeover, low valve pipe, HP pump changeover, low valve piping, valve purification, tank cleaning, drain chamber cleaning, sir main ball screening, housekeeping। ठीक है, okay।
Thank you, sir.
Thank you, sir.
Thank you for your presentation. I request the esteemed session judges to present. Mr. Manish Kumar, please stay back. I request the esteemed session judges to extend a warm note of appreciation on behalf of DVC to Mr. Manish Kumar. Thank you. Now I request Chief General Manager, Corporate Operations Services, Sri Prabhash Mandal sir, to kindly come upon the dais to felicitate, extend a warm note of felicitation to our esteemed session judges who have steered through this session of very interesting papers. We have the esteemed session judges on the dais, Sri Shanjay Sharma, Senior GM and Head SLDC, Damodar Valley Corporation, and Sri Shupriyo Sarkar, Senior GM Commercial Department, Damodar Valley Corporation. Please put up a round of applause for the session judges of this session. Thank you, sirs. All our delegates who have stayed back with us till the end of the conversations and the dialogues, you deserve a bigger round of applause. Thank you very much. I now request Executive Director Operation DVC Sri P.P. Shah to kindly come upon the podium, sir, to deliver the vote of thanks.
निकल गया सर.
So before we wind up, I would like to take this opportunity to invite my colleagues, Mr. Rajiv Ranjan Sinha and Mr. Vikram Singh on the dais, who have for the last 2 days skillfully taken you through these technical conversations and dialogues. A big round of applause for my colleagues and myself, Miheli Shamanto. Thank you so much for your patient hearing, and thank you for attending this conference. Felicitating Mr. Rajiv Ranjan Sinha, Chief Public Relations Officer, Damodar Valley Corporation. We can have a bigger round of applause, right? Now one for Mr. Vikram Sinha, Manager, Public Relations Officer, Damodar Valley Corporation. Please put up a round of applause for Mr. Vikram Sinha. Vikram Singh.
And next, Ms. Miheli Samanta. She has maintained the pace and the momentum of this conference. अजीब सा लग रहा है खुद का ही नाम अनाउंस करके खुद को ही अप्रिसिएशन लेना. Thank you for everything.
Good evening to you all. Really, on behalf of the corporate, I am very much thankful to entire management. I am expressing my gratitude And thanks to all the participants, and especially to our Honorable Chairman, Member Thermal, Sri Praveen Gupta, MD STX, Sri Ujjwal Kant Bhattacharya, Director Operation NTPC, Sri Ravindra Kumar, Director O&M WPDCL, Sri Subrato Mandal, MD Generation CAC, Sri Brajesh Kumar Singh, ex-member Finance, our member Finance, Sri Arup Sarkar Sir, ED PGCIL, Sri Ashok Kumar Nayak Sir, ED Generation CAC, Sri Sanahasis Samadar, Senior Consultant of the DVC, ED PGCIL, Sri Samir Chandra Rai, GMBHEL, Sri Sagar Nil Ghosh, Senior Consultants of the DVC, Sri Shankar Nath Bandyopadhyay, Mukhopadhyay, Member Technical Sir DVC, CBO Sir, Sri Sudhito Acharya, Member Finance, Sri Sadanand Mukherjee, and all the organizers who have untied and honestly, they have contributed a lot. I am very much thankful to all the persons, right from my corporate to the BTPS or farthest station of the Damodar Valley Corporation. We are thankful to you all. Really, it was a very nice arrangement, right from food to the presentation from anchors. I am expressing my heartfelt thanks to anchors also, all the divisions. They have really, actually we are spending so much by hiring the anchoring from the outside. We are committed to develop our esteemed engineers, esteemed fraternity from the other sections, from HR, from the finance, who are having the capability to do anything to achieve any target which is being set by the management. There is no any dearth of the merits amongst our executives. So really was a nice presentation. Actually, last year when it was organized for one day, then we thought our team also, and we are very much thankful to our member technical sir. Right in the beginning, due to election, some delay took place. But right in the beginning, when it was almost in the conceiving stage, the member technical sir told, no, it should be for 2 days. Our chairman sir was having the same opinion, because what happened in the last year, mostly presentation was from outside, and we could not develop our officers from the insides. So it was a very mind-blowing, but some of presentation were really mind-blowing, and we have to implement. I've already told you, we have to made up our mind to become a commercial officers. You think that every drop of the penny of the DVC should not go in vain. It is our commitment, and we are just finishing this O&M seminar with the commitment that through the generation, whatever we are saving, curtailing the cost, but the saving is the master stroke of all the division to save the money. And whenever we are going to purchase anything, the reasons along with its utilization must be hunted in our mind. When it will be put in our use, because the moment when we are claiming the tariff, we are putting the tariff for 5 years to the CRC, we are getting, but the time is not far from today that the consumers are very clever. They are watching each and every activities of the divisions from the top to bottom management. And for every slippage, they are taking the plea of either court of law or the CRC, they are challenging. So be very careful whether it is fuel cost, whether it is O&M cost, or whether it is fixed charge. We have to be very careful while claiming the cost, and each and every cost is borne by the DVC. So thanks, and it is our commitment to steer the DVC in the new heights in the day to come. Thank you very much.
A big kudo to our OS team and leader, Mr. PP Sir. Clap for him. बहुत मेहनत किए हैं साहब ने, और अपना साहब का टीम मेंबर्स सभी लोग बड़ी बहुत मेहनत किए हैं, रियली कुडोज टू यू। आ जाओ भाई, प्रभात जी, सब लोग आ जाओ, ऑल टीम मेंबर्स, संजय साहब, रियली वंडरफुल। और मुझे अच्छा लगा कि आप पीछे में भी अभी भी लोग बैठे हैं दैट इज रियली गुड। ऑल क्रेडिट गोज टू शाह साहब एंड टीम मेंबर्स। थैंक यू वेरी मच। अभी जितना इम्प्लीमेंटेशन करना है सभी एक्शनेबल्स को इम्प्लीमेंट करना है बस।